Welcome to the Azure Data Factory Masterclass. My name is Aleksi and I will be your teacher in this masterclass. And I will be teaching you how to build data pipelines in Azure Data Factory. After going through this masterclass and doing all the tutorials with me, you are well on your way of mastering Azure Data Factory. Before we get started, I would like to give a brief introduction to me and the contents of this masterclass. Let's start with me. I've been working with Microsoft Data Platform Stack for over 5 years now, and currently I'm working for a top-tier Microsoft partner company with headquarters in Finland that provides state-of-the-art data platforms using Microsoft Data Platform Stack. In my current role in the company, I work as a solution architect and a team leader for data engineers and architects. My personal day-to-day job still involves quite a lot of data engineering with Azure's Data Platform Stack, and thus I'm very familiar with tools in that stack. One of my favorite tools over the years has been Azure Data Factory, or commonly known as ADF. I have been using ADF daily for past 5 years now, and during those years I have accumulated a lot of knowledge and know-how about that tool that I'm now going to share with you in this masterclass. And now let's talk a bit about the contents of this masterclass and what kind of topics you will learn in this video. This video is broken down to 15 smaller lessons, and every lesson teaches you a new topic about Azure Data Factory. All of these 15 lessons are older videos that I have already published on my YouTube channel and now combined them to this one Data Factory masterclass. It is good to keep in mind that these lessons build on top of the previous lessons, and it is highly recommended to go through these lessons in order. However, if you'd like to skip some lessons or only watch a specific lesson, you can do so easily by using the timestamps that I have added to this video. Now let's go through a brief overview of the lessons we have in this masterclass. In Lesson 1, we start with an overview and the setup of Azure Data Factory. I will explain its core features and we will go through the steps to set up your own Data Factory instance within Azure. This session gives you the solid foundation to understand what ADF can do. In Lesson 2, we dive into creating a linked service to an Azure SQL database. Here I'll show you how to securely connect ADF to external sources, which is an essential for any effective data integration. Lesson 3 is all about the copy data activity. We'll use it to move data from an Azure Blob Storage to an Azure SQL database. This is one of the most common activities in ADF. In Lesson 4, we'll explore the basics of triggers. You'll learn how to schedule and automate your pipeline runs using different types of triggers, allowing you to run pipelines on schedule or in response to specific events. Lesson 5 focuses on parameters and variables. These are key to creating dynamic pipelines as they let you pass data and control values. I'll show you how to set them up and use them effectively. In Lesson 6, we cover expressions and dynamic content. This lesson will show you how to create flexible, reusable pipelines by using expressions to adapt your workflows based on runtime conditions. Lesson 7 is where we introduce conditional logic with if condition and switch activity. This allows you to create branching paths within your pipelines so your workflow can adapt to different data and situations. Lesson 8 is all about the Foreach Activity. This activity enables the iteration within your pipelines, making it perfect for processing lists of arrays, such as iterating over multiple files in a storage container. In Lesson 9, we look at the Lookup Activity. This powerful tool lets you retrieve data from configuration tables or other sources, so you can guide your pipeline's decisions dynamically. Lesson 10 introduces the Get Metadata Activity. Here you'll learn how to extract useful information from your data sources, which can help make your pipeline smarter and more adaptive. Lesson 11 is dedicated to best practices. I'll share some tips on naming conventions, error handling, and optimization techniques. Following these best practices, you will make your pipelines more robust and easier to maintain. In Lesson 12, we explore pipeline return values. This advanced feature lets you pass information between nested pipelines, which is useful for organizing complex workflows that need to share data across different levels. Lesson 13 is all about configuration. We will look at how to set up configuration-driven development, making your pipelines more adaptable by allowing them to adjust based on configuration files or tables. Lesson 14 covers the script activity. Here you will learn how to execute scripts or stored procedures within your pipelines, a handy tool for performing advanced transformations or database operations in ADF. And finally, in lesson 15, we'll work with JSON data, moving it from Azure Blob Storage to an Azure SQL database. This lesson teaches you how to handle semi-structured data formats and integrate them into your data workflows. Before we get started, it is good to know that many of these tutorials will require you to use some files, and all of those files can be found by clicking the link in the description. Also, the production quality of the videos will improve when the lessons progress, since these ADF videos were the first videos I ever made to YouTube, and during those videos I learned a lot about creating videos. But now, without further ado, let's get started with the lesson 1. This is the part 1 in this video series, and in this video I'm going to go through the basic concepts of the Data Factory, show how you can deploy your own Data Factory to your own subscription in Azure, and then show a quick demo how you can use the Data Factory to copy data from blob storage. Okay, let's dive in. Okay, Azure Data Factory, what is it? Basically, Azure Data Factory is a cloud-based data integration service running on Microsoft Azure. It enables the creation, scheduling, and management of data pipelines to move and transform data. It offers over 100 different connectors to Azure and non-Azure services that include a lot of relational databases, software, and other kinds of systems. It has this very intuitive and easy to use drag and drop interface where you can drop in your activities and start to build your pipeline very conveniently. Let's talk about the costs. How expensive is this tool to use? It kind of depends how you use it, because it's based on the pay-as-you-go pricing model. So basically it can be crazy expensive or doesn't really cost anything. So it means that there is not really an upfront cost for setting up the Data Factory, but you will pay for the computing power that you use. This kind of a basic cloud setup that you pay for the resources that you consume. So it kind of depends. If you have just a tiny pipelines moving a few kilobytes of data, or you have huge pipelines moving hourly terabytes of data, then the cost of the Data Factory is going to be a lot different. Now let's cover a very typical use case for Azure Data Factory. Let's imagine a situation that we have some imaginary company and they have their on-premise servers and they are running their CRM system there and their SAP system there. But this company has also an Azure environment, and in this environment they have their centralized analytics database, which they are using for their company-wide analytics. They have a lot of Power BI reporting built on top of that database. And now they would like to get the data from their CRM and ERB to this centralized database. How they would do that? Of course, the obvious answer is Azure Data Factory. Azure Data Factory can pull in data from both of these systems and write it to that centralized analytics database, so it is available for Power BI reporting to use. So, what do you need if you want to try out the Data Factory? First things first, you would need some type of Azure environment, meaning an Azure subscription. Then what you need is an Azure account to log into that subscription. Third thing that you need is a resource group in Azure. And I'm not going to cover resource group in much detail in this video, but basically you can think of it as this kind of a container for all of your Azure resources. So it kind of logically groups them nicely together. And last thing that you would need is a sufficient access to be able to create the Data Factory. But if that is your own Azure environment, then that shouldn't be an issue. Now we have covered the very basics of Azure Data Factory and we have core understanding what kind of tool it is. So the next step is to deploy Azure Data Factory to our Azure subscription. Okay, now we are in the Azure portal. So as you can see, I have my Azure subscription, I have my Azure account, and I know that I have sufficient access because this is my own Azure subscription. So what we still need is a resource group. So let's create one. I will open a resource groups tabs, click create, change the location to West Europe because that is the big data center closest to me. And then I'm going to name my resource group. And it's always good to think about the naming convention for your Azure resources. Okay, I click next, no tags needed. and then I'm ready to create the resource group. Now it's done. We can now go to our resource group, click create, search for Data Factory in the marketplace, click create, and name our Data Factory with appropriate naming convention, and then change the location to West Europe as well. And we will create the Data Factory v2 because the v1 no longer exists and we wouldn't want to use that anyways. No Git configuration needed, and no need to touch network, advanced, or tags. Now we can just proceed to the creation of the resource. Hit create, and then Azure starts to deploy your Data Factory. This could take a little while, but usually it's not too bad with the Data Factory. Some other Azure resources take way longer to be deployed. Okay, now the deployment has been completed, and let's refresh our resource group until we have the Data Factory there. Now it's there. Let's open it up and launch the studio. Okay, now the studio is opening up. And first things first, let's enable the dark mode, because we do not want to burn our eyes with this very bright UI. And now let's have a quick tour around the Data Factory UI. On the left sidebar, we have the buttons that will take us to all the different sections of Data Factory. First in the list, we have the Home button. Then we have the Author button that allows us to create pipelines. We can check that out now. So basically, this is the place where you can craft your data pipelines. I will now quickly demonstrate to you how the pipeline creation happens in the Data Factory UI. So basically, we can click here and select New Pipeline. This opens up the pipeline development view, and now we can click through the bunch of activities that we have here available in the Data Factory. Basically, these are your transformations for your data pipeline. And now we can throw a couple of them to the pipeline just to demonstrate how the development process happens in the Data Factory. Of course, we cannot really do anything with those now because we don't have any datasets or linked services here in the Data Factory. Here in the development view, we have few other objects that can be created, but we are only gonna cover datasets in this video. So here we could click a new dataset and we would be able to create a dataset to some linked service. For example, to a blob storage, some random file. Okay, let's continue the UI tour and go to the Manage tab. This is the place where you can build your linked services. And setting up the linked services allows you to connect to different data stores. As you can see, we have a huge list of data stores and resources where we can natively connect with the Data Factory. And this list is ever expanding thanks to Microsoft. But for now, we are not going to create any linked services. And then the last tab that we're going to cover is the Monitor tab, and here you can monitor your data pipeline runs when they're running, but we don't have anything running right now. So this looks completely empty for now. Okay, now we have our own Data Factory up and running. So next, we are going to dive a little bit more deeper into those core concepts of Data Factory, meaning to linked services, datasets, activities, and pipelines, and explain a bit what they mean and how those concepts tie together. So let's dive into it. Okay, let's cover Data Factory's core concepts in a bit more detail. Let's start with the linked service. Basically, linked service is a connection to an external resource like SQL database. And then we have a dataset, which is kind of a metadata about the actual data in some linked services. You can think of it as an instructions for Data Factory to receive data. Then we have an activity. Basically, this is your processing step in a data pipeline. And then finally, we have the pipeline that logically groups activities together and forms your actual data pipeline. And now let's digest all of these concepts a little bit more. Let's start with the linked service. What is it? Basically, it links your data store or external compute resource to Data Factory. Linked service stores the connection information to your external data store, like, for example, SQL database, the connection string, or the connection info, how to access that data store. It also handles the connection in a way that on Data Factory side, you don't really have to code at all or worry about drivers or anything like that. Currently, Data Factory supports over 100 different linked services, along with some very general ones like ODBC and REST that allows you to connect to even more data stores that are not really natively supported as a linked service yet. Next, let's cover dataset in a bit more detail. Basically, you can think of it as an object in Data Factory that will point to some data in the linked service. For example, we could use a dataset to describe a CSV file in blob storage. This dataset would contain information on that file. For example, what is the container in the blob storage where that file can be found, and what is the exact path to that file, and what is the file type, and what is the separator. So when Data Factory goes and picks that file up, it has the instructions to read it. Next, we have activities. Basically, activities are your processing steps in your data pipeline. And these activities often consume data sets. For example, if you're copying data from place A to B, then you would need data sets in order to do that, because otherwise Data Factory wouldn't have any instructions for copying the data. Activities can be roughly divided to 3 different categories. First category is data movement activities. These are basically your copy data activities that copy data from set data store to another data store. Then we have data transformation activities. These are your external computing resources that you can link to Data Factory. For example, if you want to run some Python logic in Databricks notebook and run that as part of your pipeline, you can do that. Or run a stored procedure in SQL database, or maybe implement an Azure function as part of your data pipeline. Then the last group is control activities, and control activities are used for the pipeline control flow. For example, if you want to put some conditional logic to your pipeline or receive metadata about some files, these are basically your control activities. And when we start logically grouping activities together, we get a pipeline. So basically, as an example, in the pipeline first, we could have a copy data activity that would copy data from the SFTP server to Azure Blob Storage. This would be the activity number 1 in our pipeline. Next, we could have a Databricks notebook that would read the data from the Azure Blob Storage and run some Python calculations for that data, and then write it back to an Azure Blob Storage. Lastly, we could have another copy activity that would then copy that refined data from Azure Blob Storage to Azure SQL database, for example, for reporting purposes. And here we have an example how this kind of pipeline would look like in the Data Factory UI when we would actually build this in Data Factory. Now I hope you have some type of understanding what is a linked service, what is a data set, what is an activity, what is a pipeline, and how all of those concepts tie together. Next, we are going to do a quick demo where we are going to copy some data from blob storage back to the same blob storage. I'm not going to explain in detail in this video what is a blob storage, but for now you can think about it as our file system in cloud. Now let's create a blob storage. For that we will need a storage account. Let's go to the marketplace and search for storage account. Here we have it. Now let's create one. Okay, click create. And subscription is correct, resource group is correct. Now we need to give it a name. Again, pay attention to your naming conventions. I'm naming this with my naming convention that I have been using in this environment. Also, the region is already correct, West Europe, that I want to use. And everything else is fine, and we didn't don't need to touch any other settings, so we can just proceed to the review step and create this storage account. Okay, let's create it. Now it has been deployed, and let's go to our resource group, and there it is. Now let's open up our storage account and let's create few blob containers here. Okay, so I will create first one container, and I will give it a name that will describe the use case for this specific container. It's going to be demo1 source. And let's create that. And now let's create another one, demo1 sync. Okay, create that. And now we have two containers here. Okay, cool. Next, I will give Azure Data Factory access to those blob containers that I just created. I will use Azure Data Factory's managed identity for giving that access. Managed identity is kind of out of scope for this video, but you can think of it as giving Azure Data Factory a permission to access those. Basically, if you think about Azure Data Factory as a person that we are giving access to blob containers, I'm going to give this access on the resource group level. So I will go to my resource group access control and click add new role assignment and search for blob data contributor, because this role will allow Azure Data Factory to read, write, and delete blobs in the blob container. And that should be enough. We want to select the assign access to managed identity and then find our managed identity here in the list. There it is. And now let's assign it. Let's click review and assign. Cool. Now Azure Data Factory has access to our blob containers on resource group level. Okay, let's go back to the Data Factory. Let's go to Manage and then to Linked Services and click New. Here we have Azure Blob Storage. Let's create a new linked service for blob storage. And again, use the naming convention that you are comfortable with. I'm gonna name my linked service for now with the LS. That means linked service underscore ST, which means storage account, and then underscore stage, which means this kind of a staging area for data. This is going to be my naming convention for now. And then for the authentication type, let's use system assigned managed identity. And next, we need to type out the service endpoint, meaning the blob storage address. Basically, the blob storage address is https your storage account's name.blob.core.windows.net. After we have typed that out to the service endpoint field, we can test the connection. It should be successful. Yes, it is. And now we can create the linked service. Let's hit create. Okay, now we have created our first linked service. And when we want to save in Data Factory, if we don't have Git configured, we can click this publish button. And this will basically save these changes to the Data Factory. Next, let's upload some data to our source container. Let's find our source container here, and then we can click upload. Now I will drag and drop here one file. The file that I uploaded is just a basic txt file with some little content in it, but because we are going to perform a binary copy in Data Factory, we don't really need to care about the file contents at this stage. So basically, we are just moving a binary block from place A to B, and A place will be our source container and B place going to be our sync container. Now let's go back to the Data Factory and create our first pipeline. And for pipeline creation, we need to open the Author tab and click Pipelines. And from those three dots, click New Folder first, because we want to stay organized here. And then click New Pipeline. This will open the pipeline development view. Here we can remind ourselves that there are plenty of different activities to choose from in the Data Factory, but today we are only going to use one of these, and it is going to be the copy data activity, which is found on top of the activity list. It's one of the most basic and most used activities here. So let's drag and drop that in. And now we would need to configure the source and the sink. But before that, let's name our copy data activity accordingly, so we know what is it doing. It's always good to name your activities so that they reflect the purpose that you are using them. Okay, so we don't have any datasets created, so we need to create a new one. And we can do it from the datasets tab. And let's create a new folder for that one as well. Name it in the similar way than our pipeline folder. Let's click create. And now let's create a new dataset. Let's select Azure Blob Storage, select binary, and then let's name our dataset according to good naming conventions. And then let's select the linked service that we want to use that we just created. And now let's go find our dataset in that linked service. Okay, it's there. And now we can create it. Now we can go back to our pipeline and configure our pipeline source to use this dataset that we just created. Okay, now it has been configured. Nice and easy. But we still need a sink dataset. So let's repeat this process one more time. Let's create a new dataset, Azure Blob Storage, select binary, and then again name the dataset accordingly so we can keep this data factory nice and organized. And then select the linked service. And after this, we need to configure the file path. Now we are going to choose the sink container. And since we don't have any files there yet, we leave it as so, and we write our file name here. I'm going to change the file name slightly. Now let's click OK. So now we have the sink dataset, so we can go back to our pipeline and configure that to our sink. And ta-da! Now we have successfully configured our copy data activity. Before we are going to test this, I will change the pipeline name to something else than just pipeline 1, because I like to be organized, like I have multiple times during this video. And let's type something that reflects what this pipeline does. So I will say that it's PL demo1 copy from source to sink. Not the best name, but goes for now. So now we can proceed to testing part. We can hit the debug button here and try this out. By hitting this debug button, I will trigger a test run for my pipeline. And now I need to wait a bit until it will complete the test run. This shouldn't take more than a few seconds. And now it's already done. We can check what happened. So files read 1, files written 1, seems to be correct. Now let's go back to our storage container and check if there is a new file in our sink. And we have the copied data.txt here. So everything went fine. Okay, now last thing that we can do is to publish all these changes since our fancy pipeline is now working. And now after we have published those, we have saved these changes to our data factory. And we are basically done with this demo here. Okay, that's everything that I wanted to cover today. I hope you got the overall idea what is Azure Data Factory as a tool and what is it used for. Don't worry if some of the topics in this video were left a bit unclear, since we are going to come back to those and cover them in way more detail in upcoming videos. This is the part 2 in this series, and in this video we are going to create a linked service from Data Factory to Azure SQL database using Data Factory's system-assigned managed identity. If managed identity is not a familiar concept to you, don't worry, I got you covered, since I just created a video on those where I explained thoroughly what are managed identities and how you use them. The link can be found in the description. Now let's dive into today's subject. Linked service from Data Factory to Azure SQL database. Okay, let's start with our setup here. We have a Data Factory and then we have an SQL database. And now we would like to build a linked service between these two. But before we can start building that linked service, we have to consider a few things. First, we have to consider the Azure resource that encapsulates the SQL database, and that is Azure SQL Server. I'm not going to cover SQL Server and SQL database as Azure resources in that much detail in this video, but the main thing that we need to consider with the SQL Server is the SQL Server firewall, and we need to make sure that Data Factory is able to access through that firewall to that SQL database. Inside that SQL database resource in Azure, we have the actual database itself. And in that database, we have some database tables that we would like to write some data into, or maybe in some cases read data from those tables. But how we are going to get access to those tables, it's a bit different than with the blob storage that we covered in the previous episode, since in this case there is no Azure role-based access control role that would grant us the access to that database and to those tables. However, the actual database itself supports AD authentication, even though it doesn't support role-based authentication from the Azure portal. But this means that we have to create a user for the Data Factory to that database. We can create that user by using Azure Data Factory's system assigned managed identity, and then grant sufficient access for that user to access those database tables. After we have done that and made sure that there is a firewall opening in the SQL Server firewall for our Data Factory, and then we can establish the linked service between SQL database and Data Factory. Now you should have a basic understanding how linked service from Azure Data Factory to Azure SQL database works. Now let's hop into the Azure portal and see how we can do this in practice. Now we are in the Azure portal and in the same resource group that we created in the previous video. Next, we would need to create SQL Server and SQL database to this resource group. So let's go to the marketplace and search for SQL database. Here we have the SQL database. Let's click that and let's create one. Next, we need to check that our subscription and resource group are correct. They are. And then we need to name our database according to our naming conventions. Then we need to create SQL Server for our database. So let's create that and enter a name for it. I will change the location to West Europe because that is the big data center closest to me. Then we need to set up Azure AD admin for this database. Basically what this does, it will allow admin access for a set user or a user group to this database to manage it. And because this is my subscription and I'm the only user here, I will select me as the Azure AD admin for this database and the server. Now we can click OK. And then we can adjust our workload and compute and storage for the database. We would like to change the workload environment to development. Then we can configure the database and select the cheapest possible option, and that is basic with 5 DTUs. This will be around $5 per month. Then we can move forward. No need to change any other settings on this page. Then we can go forward. No need to touch the network settings and no need to touch the security settings or additional settings or tags. So we can just review and create this database. Now our database and the server are being deployed, and this can take actually quite a while. So with some YouTube magic, we can now speed things up like this, and now our deployment has been completed. Next, let's go back to our resource group, and here we can see our SQL database and our SQL server that we just created. Next, let's open our SQL server and configure the firewall settings. Let's go to security and networking, and let's change the public network access to selected networks. Now this would reveal my IP address, so I will hide it. And first I will create a firewall opening for my own IP address, so I will be able to access this SQL server from my home network. I will name this firewall opening as Aleksi Home. And next I'm going to allow Azure services and resources to access this server. And what this does, it will allow any connection that is coming from resources in the Azure to connect this SQL server. In some environments, this option is probably not allowed to be used, and you have to consider some individual IP addresses for each resources that will be used. But to keep things simple here, I will just allow all the Azure services to access this server. And by allowing them to access this server, it doesn't mean that they can go and get some data from my SQL database. This just allows them to go through the firewall, but if they don't have access in the database to log into that database, they are not able to do anything there. So I just wanted to clarify that a bit, so it's not so scary as it sounds, but still, we will now enable that. Let's save these settings here. And now let's open a program called Microsoft SQL Server Management Studio, or SSMS, that will allow us to connect to our SQL server. Our SQL server connection or server name is our SQL server resource name .database.windows.net. And we want to use Azure Active Directory with universal MFA to log into that database. And after pressing the connect, it should prompt us with the prompt in our browser that will allow us to authenticate to the database. And after we have connected successfully, we can navigate to our SQL database. As you can see, I only have now one database tied to this SQL server that we just created. And now we can open the users. As you can see, we have only few general users that are created by default, and next we would need to create a user for our data factory. And I will now write some TSQL here that will allow us to create that database user for the data factory. So I will write create user, our data factory name from external provider, which will create a user for the data factory to this database. And then I will create alter role, DB owner, add member, our data factory name, which will give the database owners for our data factory to this database. And this DB owner is something that you really need to consider in your environment, that is it okay to grant DB owner to data factory, or should you use some other role, since DB owner grants very, very wide access to the database and allows you to manage many things there that probably in some environments is not really okay. But again, when keeping things simple, I will now grant that DB owner for that data factory, so I'm able to do pretty much everything with the data factory in this database. Now I will execute these 2 lines of code, and it will create that user and grant those rights for that user. Code ran through successfully as expected. And now we can refresh the user list, and we should see our data factory user in this list. And there it is. Everything seems to be going according to our plan, and everything is working. So now let's jump into data factory and create the actual linked service. Let's open the manage tab and let's click new. And now let's search for the SQL database. There it is. And let's create a linked service for that. Again, let's name our linked service according to our naming convention here. And now we have to select our Azure subscription, server name and database name, and then we will change the authentication type to system assigned managed identity, and then we can test the connection. The connection is working, so everything is fine. So now we can just click create, and now we have successfully created a link service to our Azure SQL database from our Azure Data Factory using system assigned managed identity. In this video, I will show how you can copy CSV file from the blob storage to Azure SQL database. This video is already a part 3 in this series, and in the previous 2 videos we have already covered how to create a linked service to blob storage and how to create a linked service to Azure SQL database. If you are not familiar with the linked service concept, please watch those videos before watching this one. Links to those previous videos can be found in the description. Now let's get started with today's subject. Let's start with today's setup. We have a storage account. In that storage account, we have a blob container, and in that blob container, we have a CSV file. Then we have a SQL database, and in that database, we have a database table. And now we would like to use the Data Factory to copy that CSV file and its contents to that database table. But before we can do that, we have to describe the CSV file to the Data Factory. And in Data Factory, we are going to use object called dataset to describe this CSV file. First, we need to describe what is the linked service for this CSV file. In this case, it's going to be the blob storage. Then we need to tell the Data Factory what is the file path to this file. And then we need to tell the delimiter of the file to Data Factory. With the CSV file, it's going to be comma. And then we need to tell, does our CSV file have a header or no? And this CSV file has a header. And because our CSV file has a header, our Data Factory can automatically read the columns from that file. And then we can use this dataset as instructions for Data Factory in order to read the data. Next, we have to describe the database table for the Data Factory. So we will also create the dataset for that table to the Data Factory. We need to describe the linked service. Now it's going to be SQL database. Then we have to tell the table name. And after we have given the table name, Data Factory can read the columns from the actual table. Then we can use these as an instruction for Data Factory to write that data to the database. After we have done all this, we can just configure the copy activity and let the Data Factory to handle the copy. Now we have covered in theory how to copy a CSV file from the blob storage to Azure SQL database. Next, let's go to Azure portal and see how we can do this in practice. Now we are in the Azure portal. Let's first open our storage account and open our blob containers. Here I have already created a container for us for this tutorial. Here we can see that I have already uploaded a CSV file called azure.csv. We can check the contents of the file and we can see that there are 5 rows and one of those rows is the header for the file. There is data about the Azure resources that I currently have in my resource group. So our source dataset is fine. Next, let's open SSMS and configure our sync dataset that is going to be the database table. Here I have few lines of SQL code. First line will create the schema and then create a table to that schema. Now let's run this code. And now let's refresh the tables. And here we have our database table that we are going to use as a sync in this tutorial. Let's go back to the Data Factory and let's create a new folder for the tutorial 3. Then let's create a pipeline to that folder. And again, let's name this pipeline according to our naming conventions that we're using here in the Data Factory. Then we have to create 2 datasets, one for our source and one for our sync. Let's start with our source. Let's go to the datasets and let's create a new folder so that we can stay organized here, and let's create a new dataset to that folder. And now we want to choose Azure Blob Storage, and then we want to select delimited text as our file type. And again, let's name our file quickly so we can recognize these when our Data Factory gets crowded with objects. And let's select our linked service, that is our blob storage. And then we can go and find our dataset in the blob storage using Data Factory UI. After we have selected our dataset and selected first row as header, then we can click OK and create the dataset. After we have created our dataset, Data Factory gives us a bunch of other options that we could change with the dataset. For now, these options are good, and we can actually test that Data Factory reads the data fine by clicking the Preview Data button to see how the data would look. Our data looks fine to me, so all the settings should be now correct. So now we can proceed to configuring our sync dataset. Again, let's create a new dataset, and now let's find Azure SQL database. There it is. Let's click that, and then again, let's name our dataset. Next, we want to select the linked service, and then we can select our table from the table list, then click OK. As you can see, with the SQL database table, we don't have that many options that we can change with the dataset, since the SQL database table is very standardized format and there is not really that much room for us to do some tweaking with the actual data. Now we can go back to our pipeline and add new activity to our pipeline, which is going to be copy data. Then let's name our copy data appropriately. And next, we can configure our source dataset. And our source dataset is going to be the CSV dataset that we just configured. And then we can configure our sink. That is going to be our database table. There are a lot of options that we could now change with our source and sink dataset with the copy data activity, but we are not going to cover those in this video, so we leave everything as default for now. Then we can open the mapping tab of our copy data activity and import our schemas, so we can see how the Data Factory would map our CSV file to our database table. After Data Factory has imported our schemas, because the column names are the same in the CSV file and in the database table, Data Factory can easily automatically map these. If these would be different, then you would have to do this mapping by hand and select which source column would map to which sink column. But now everything is set here. So next we can try to debug our copy activity. Let's press the debug button. So our copy activity will start running. This should only take few seconds since we are moving only few rows of data. And now it is already done. We can check that rows read 4 and rows written 4. So according to this, everything seems to be fine. Then we can check our database and check our table. Do we have any rows? So let's select everything from our database table and let's see what kind of rows we have there. And everything seems to be okay. So now we have successfully copied contents of the CSV file to the database. Today's topic is going to be Data Factory triggers. In this video, I will cover the basics of Azure Data Factory triggers. After watching this video, you should have an understanding what are the different types of triggers in Azure Data Factory and how you can configure them and use them to orchestrate your pipeline runs. Let's start by covering all the different types of triggers in Azure Data Factory on conceptual level before covering them in practice in Azure Portal. So let's dive right in. Before diving into different types of triggers in Azure Data Factory, let's just first cover what is a trigger in Azure Data Factory. Let's start with our setup here. We have Data Factory pipeline that is copying data from Azure Blob Storage to Azure SQL database. And we would like to get this pipeline triggered. And like the name implies, the trigger is the activity in the Data Factory that will trigger the pipeline and initiate the pipeline run that will copy the data from Azure Blob Storage to Azure SQL database. Now, when we have the basic understanding what is a trigger, we can cover the different types of triggers in Azure Data Factory. First, we have a schedule trigger that is your basic time-based trigger. Then we have a tumbling window trigger that is also a time-based trigger, but triggers the pipelines in set intervals and adds a bit more complexity to configuration compared to schedule trigger. Then we have a storage event trigger that triggers the pipeline based on events that happen in storage account. Then we have a custom event trigger that triggers the pipeline based on custom events. And finally, we have the last trigger that is manual trigger, when you act as a trigger and trigger the pipeline from the Data Factory UI. Now let's cover schedule trigger in a bit more detail. And here we have the schedule trigger configuration, how it can be seen in the Data Factory UI. Let's digest this configuration in a bit more detail. Firstly, schedule trigger is a trigger that executes a pipeline on a regular schedule, meaning that we can say that execute this pipeline once per day at 11 a.m. We can configure also a time zone for this execution, and you can set it to your time zone if you want so. We have the configuration from the minute level to month level, so we can say, for example, execute this pipeline every 15 minutes or execute this pipeline every 30th day or last day of each month or so on. This trigger is fire and forget type, so it doesn't care what happens to the pipeline after the trigger has fired, and there is no way, for example, say that if the pipeline fails, please try to rerun it for a couple of times or so. And this difference will come a bit more clearer when we cover tumbling window triggers after the schedule trigger. The relationship with the pipeline with this trigger is many to many, meaning that one pipeline can have multiple schedule triggers and one schedule trigger can trigger multiple pipelines. Now let's go through a quick visual example how the schedule trigger works. First, we have the trigger configuration. Our trigger type is going to be schedule. Our start date is going to be January 3rd, 4 p.m. Our time zone is going to be UTC. and our recurrence is going to be daily at 11 a.m. So let's start running our timeline here. First, our trigger is created on January 1st, 9 a.m. Then our start date is set to January 3rd, 4 p.m., which means that the first time when our trigger will actually execute is January 4th at 11 a.m. When our trigger runs, it will trigger two pipelines because this schedule trigger is tied to two pipelines, pipeline 1 and pipeline 2. And they both start running after the trigger has executed. But our pipeline 2 fails, but nothing happens and it will stay in the failed state because in this trigger we don't have any policies to say that try to run that pipeline again if it fails. So we move forward. Then our second execution will happen on January 5th at 11 a.m. and again two pipelines, pipeline 1 and 2 are being executed. Now let's move forward to January 6th at 11 a.m. and our pipeline 1 is still running when our trigger is executing. However, our trigger doesn't care about the pipeline still running. It will start again two new pipeline runs for pipeline 1 and 2, and then we have a situation that our pipeline 1 is running at the same time. And this can be problematic in your environment. And there are pipeline level configurations that we can use to prevent this, but in the trigger itself, we don't have any configuration that would prevent this situation. In the tumbling window trigger that we're gonna cover next, we have options to prevent this situation. Tumbling window is also a time-based trigger, and here we have the configuration for the tumbling window trigger as it's seen on the Data Factory UI. Tumbling window trigger is a bit different to schedule trigger because it executes a pipeline on a regular interval. So basically we can say that execute this pipeline every 1 hour or every day since the start date. So the start date and the time is the time when the intervals will start happening. Tumbling window offers way more configuration options compared to the schedule trigger, and it also supports this kind of a historical backfill that we can run it on tumbling windows that have happened in the past, but we're not going to cover this functionality in that detail in this video because we're going to come back to this after we have covered Data Factory parameters, because after we have covered those, this historical backfill will make much more sense, and for now it would have been bit too confusing to cover in this trigger basic video. Like the schedule trigger, we have the configurations from the minute level to month level. And this trigger actually supports dependencies to other triggers that the schedule trigger does not. And this is also a feature that we are not going to cover in that much detail in this video, but just keep in mind that with this trigger it is possible. And this trigger has concurrency and retry policies that were troubling in our previous example. So we can say that we only allow one instance of this trigger to be running at given time. And we can set a retry policy that if the pipeline fails, please try to run it for a few times. We can also define the interval in seconds, how fast the trigger will try to rerun the failed pipeline. This trigger has a one-to-one relationship with the pipeline, meaning that we can only have a one tumbling window per pipeline, and that's it. So we cannot have multiples like we could have with the schedule trigger. Now let's also do this quick visual animation for the tumbling window trigger to see how it works in the Data Factory. Let's first have our trigger configuration. Now our trigger type will be tumbling window, our start date will be January 3rd, 11 a.m. and we say that we want to run this tumbling window trigger every 24 hours. Concurrency for this tumbling window will be 1 and retry will be also 1. And now let's start running this on our timeline. First, our trigger is created on January 1st, 9 a.m. Then we have our start date, that is January 3rd, 11 a.m. So our first execution will be 24 hours after the start date on January 4th, 11 a.m. And it will start running our pipeline 1. However, our pipeline 1 will fail, but since we have defined the retry policy, the tumbling window will try to run it again. And now our pipeline succeeds and everything is fine. Let's go to our next execution that will happen on January 5th at 11 a.m. It will again trigger our pipeline 1 and it will start running. However, now our pipeline 1 takes way too long to run and it will overlap with our next tumbling window that will be on January 6th on 11 a.m. And what happens now is that since we have defined the concurrency to be 1, we cannot start running the pipeline again with this trigger. So we move forward until the pipeline has finished, and after that we can trigger our tumbling window trigger again, and that will be now on January 6th at 2 p.m. and then the pipeline 1 will start running again. As you can see, the tumbling window is a bit more difficult to configure and understand, but it will solve some issues that schedule triggers might have. Now let's just do a quick side-by-side comparison between these two time-based triggers so you really get the idea how they are different and you can choose the right trigger for your circumstances. The schedule trigger runs on a consistent time schedule and the tumbling window is a fixed interval. Schedule trigger is a fire and forget type, meaning that it doesn't care about the pipeline state at all and it will just fire and forget the pipeline after that. But the tumbling window waits for the pipeline state, so it is interested in how the pipeline run actually went. In the schedule trigger, we do not have pipeline level retries, but in the tumbling window, we have those. The schedule trigger doesn't support any dependencies to other triggers, but the tumbling window does support them. Schedule trigger does not support any kind of concurrency, so we cannot define that we can have only like one or two of this schedule trigger running at the same time, and this comes from the fire and forget nature of the trigger. But in the tumbling window, we can define the concurrency that we want. Schedule trigger has many-to-many relationship to pipeline, so we can trigger multiple pipelines with one schedule trigger, and we can have multiple schedule triggers tied to one pipeline. However, the tumbling window relationship is one-to-one, so we can have one tumbling window per pipeline, and that's it. Next, let's cover storage events triggers. And here we have the Data Factory configuration for storage events triggers. And what this trigger does, it basically executes the pipeline based on a storage event that happens in the Azure storage account. Supported events are blob created and blob deleted. And we can configure some things related to those blobs. So we can say that the blobs in the set path that have certain ending only count as events for the trigger. And like schedule trigger, this trigger is many-to-many relationship with the pipeline, so we can have multiple storage event triggers tied to one pipeline and multiple pipelines tied to one storage event trigger. Next, let's run this same visual timeline animation for this trigger in order to see how it actually works in the Data Factory. Let's start with our trigger configuration. Our trigger type is now going to be storage events, and we define that the blob path must end with .csv. And our event is going to be blob created. So we are only monitoring blobs that are being created to the storage account. And we are going to ignore empty blobs. So we are not allowing our trigger to fire if the blob is empty. Now let's start running our timeline here. Our first blob has been created to the storage account and it matches with all the criteria that we have defined. So it will run our trigger. It will trigger two pipelines because we have configured this trigger to run pipeline 1 and 2 and they will start running. However, the pipeline 1 will fail, but the trigger doesn't care about that because we don't have any retry policies that we can configure for this trigger like we have in the tumbling window trigger. Next, our second file is created and that file also matches with our configuration. So it will trigger the pipeline run and it will again trigger pipeline 1 and 2. And our third file has been created, but this time this file is empty, so it doesn't trigger any pipeline runs because we have decided to ignore empty blobs. Our fourth file has been created, but now it has .txt ending, so it won't trigger any pipeline runs. Our fifth file has been created and it has the .csv ending and it's not empty, so it will run our trigger and this will trigger our pipeline 1 and 2. However, our pipeline 1 from the previous trigger is still running and now we have again the situation where our pipeline 1 is running two times at the same time because in this trigger we cannot define any concurrency in the trigger configurations to prevent this from happening. Lastly, we have the custom events trigger. And here we have the trigger configuration as it can be seen in the Data Factory UI. Basically, this trigger executes a pipeline based on a custom event that comes from the Azure Event Grid. And Event Grid is this kind of a messaging service in Azure that allows sending messages between Azure services. This trigger allows very flexible trigger integrations that you could trigger Data Factory pipelines from an event that happens in your other Azure applications. However, this is the most complex trigger to implement And we are not going to cover this trigger in much detail in this video because I would consider this to be very lengthy and advanced topic to cover. So leave a comment to the comment section down below if you would like to see a dedicated video on custom events on this channel. This trigger has many-to-many relationship with the pipeline. So like with the storage event trigger and the schedule trigger, you can have multiple custom events triggers tied to one pipeline and tie multiple pipelines to one custom events trigger. Now you should have a basic understanding what are the different types of triggers in Azure Data Factory and how do they work. Now let's open the Azure portal and see how we can use these triggers in practice. Now we're in the Azure portal, and let's first open up our Data Factory, and you can see that I've already created several pipelines for us to use in this demo under the tutorial 4 folder. All of these pipelines just have a simple wait activity inside them, and what wait activity does, it will wait given amount of seconds. So basically our pipeline will run the amount of seconds that I have defined in the wait activity. And these wait pipelines are enough for this demo because now we are just going to demo how the triggers work without caring too much about the actual pipeline, what it does. Now let's first create a schedule trigger. Let's open our Manage tab and let's navigate to triggers. Here we can click New and create a new trigger. Let's name the trigger according to our naming conventions. I'm going to start my trigger as trg_tutorial4_demo1_schedule. And now let's configure our trigger. Our trigger type is going to be schedule. Our start date is going to be as it is because the Data Factory defaults the start date to the current time. Then the time zone is fine. We can use UTC. And then the recurrence, we want this trigger to be running every 5 minutes. And then we can click that we want to start this trigger after we have created it. Lastly, we can just click OK and the trigger will be created. Next, we need to tie this trigger to our pipelines. So let's go back to the Author tab and let's open our pipelines and let's click Add Trigger. And here we can select our trigger and select OK. And we don't have any parameters, so let's click OK. And now we have successfully added this trigger to our first pipeline. Next, let's repeat this same process with our second pipeline. Let's click OK and OK. And now we have added this schedule trigger to 2 pipelines. Now we need to publish those changes so our trigger will start actually running. So let's do that. Now our publish is being done, should be done fairly soon. Now it is done. So now we have activated our first trigger in this Data Factory. Now with some YouTube magic, I will speed things up and let's go to our Monitor tab and see how our trigger is performing. It has already started a run and we can see that it has started to run both of these pipelines now. We can click the refresh button here to get some fresh data how our pipelines runs are going. As you can see, our 360-second pipeline is still running, but our 30-second pipeline has already completed. We can also check the Trigger Runs tab. Here we can see that our trigger has already succeeded even though the pipeline is still running. And this is due to the fire and forget nature of this trigger, which means that the trigger is marked as succeed immediately after it has kickstarted those pipelines that it's being attached to. Now let's go back to the pipeline runs. Let's again use some YouTube magic to hop forward to the next time when our schedule trigger is ran. And now we have leaped forward in time and we can see that we have 2 new pipeline runs being triggered by this trigger. But our previous run is still going on. And now we can see, since we don't have any concurrency settings in the trigger itself, the trigger will still fire even though the previous iteration of that trigger would be still running, or the previous iteration of those pipelines that trigger has triggered are still running. Now we have gone through in Azure how the schedule trigger works, so we can go back to the Manage tab and find our trigger and pause the trigger because we don't need to be having this running in our Data Factory and generating costs here. Next, let's cover a tumbling window trigger in action in Data Factory. Let's select our Demo2 pipeline and let's create a trigger for this pipeline. Now let's create this trigger straight from the pipeline view. This is the other option how we can create triggers. So we can click here Add Trigger and then select new instead of existing triggers. Here we can name our trigger according to our own naming conventions. And now let's select tumbling window as trigger type. The start date is fine since it's the current time. And then we can select the recurrence for every 5 minutes. We are not going to add any dependencies to this trigger, and we are not going to touch on the delay setting either, but we are going to configure the concurrency to be 1, and the rest of the settings we are going to keep as default, and we're not going to add any retries since there is not really an option that our wait pipeline would fail since there are no logic in this pipeline. And we can select the start trigger on creation. Now we can click OK, and we don't have any parameters for this pipeline, so let's just click OK. And now we have successfully created our first tumbling window trigger to this data factory. Now we can click publish, so it will activate our trigger. Publish should be done fairly soon. Now it is done. And now we can start monitoring our trigger. Let's go to the monitor tab, and here we can see some previous trigger runs from our previous schedule trigger that we demonstrated before, but we are not now interested in those runs any longer, so we want to see demo 2 pipeline run here. Again, with some YouTube magic, we can speed things up and hop into our first trigger run. Now we have jumped forward, and here we can see our first trigger run for our demo 2 pipeline, and this pipeline will run 420 seconds, which is 7 minutes. So it will run longer than our 5-minute time window. Again, we can check the trigger runs tab, and here we can see a difference between the schedule trigger and the tumbling window trigger. Here we can see that the tumbling window state is running when the schedule trigger always succeeded immediately after it had triggered those pipelines, because the tumbling window trigger is interested in the pipeline state. It will wait for the return value of the pipeline, and for example, if there are retry policies defined and the pipeline has failed, it will try to retry the pipeline based on the retry configuration. Again, I will speed things up and hop a few minutes forward to our next trigger window. Now we have hopped a few minutes onwards, and we can see that our pipeline has been running now over 5 minutes, which means that our next pipeline run should have begun according our time interval that we defined for this trigger. But it is not running because we defined that the concurrency for this trigger is 1, so there can be only one instance of this trigger running at given time. Also in the trigger run page, we can see that our tumbling window is still in the running status, so the trigger is still running. Now again, let's hop a few minutes forward. Let's hop to the 7-minute mark when our trigger should be finished. Now our trigger has been running for 7 minutes, so our pipeline should be done, and it is done. Then we can open our trigger runs page, and here we can see that we have just a new tumbling window trigger starting to run, and this has triggered our demo 2 pipeline. And because we defined that concurrency setting, we didn't have 2 demo 2 pipeline runs running at the same time. Now we have gone through the basics of tumbling window triggers, so we can go to the manage tab and find our trigger and pause it because we don't want it to be running here in the data factory. The last trigger that we are going to cover in this video is going to be storage events trigger. And now let's add a storage events trigger to our demo 3 pipeline. Let's click add trigger, and let's select a new trigger since we don't want to use any existing ones. Let's name our trigger according to our naming conventions. Let's select the storage events as our trigger type, and now let's select our storage account that we created in the previous videos. And I have already created a new container to the storage account that we are going to use for this demo. And let's select that. And now we want to set our configuration so that our blob path ends with .csv, and we want to only monitor blob created events. And we will be ignoring empty blobs. And our trigger will be created on creation. Now we can click continue. And now Data Factory is trying to find some blobs from that container that match to our configuration, but there are none yet. So we can just click continue. And then we don't have any parameters, so just click OK. Now we have created the storage event trigger, so we have to publish that, so it will be activated. Now let's wait for a few seconds for our publish to finish. It should be done any second now. Now it is done. Now we can navigate to our storage account and find our blob container that we are going to use in this demo. Let's open that. And now we can start uploading files and see what happens in Data Factory when we do that. Let's first upload our file 1.csv, And this file has some content in it, so meaning that the file is not empty. This file should match all our configuration specs and it should fire our trigger. Let's see what happens. Now I will again speed things up a bit and let's hop into our data factory where we can see that our demo3 pipeline has already ran once. So everything worked fine. And in the trigger runs page, we can see that we have one storage event trigger that has fired. Now we can go back to our storage account and upload our second file. This is going to be file2.csv and this file has some contents, so it should trigger a new Data Factory pipeline run. And the demo3 pipeline is running once again. Let's upload some more files. Let's upload file3.csv, but this file is now empty, so it shouldn't trigger our pipeline run because we have ignored empty files. And as we can see, we don't have any new pipelines running here. Okay, let's go back to our storage account. Let's upload file number 4. This time it's called file4.txt. So because it has the txt ending, it should not trigger any new pipeline runs. And we can confirm that in the data factory. We don't have any new pipeline runs. And then we can upload file 5.csv, and this file has content, so it should match our criteria, that is .csv, and it has content. So let's see data factory that did this file start any new pipeline runs. And in fact it did, and we have that previous run just finished when that one started. But because storage events trigger is also fire and forget, it doesn't care about that if the previous run is still running or not, so they could be running at the same time. Now we can go back to the Manage tab and also disable this storage events trigger because we don't really need it for anything. In this video, I'm going to cover Data Factory parameters and variables. These two concepts are crucial to learn in order to build more dynamic and efficient pipelines in Data Factory. This video is part of my Data Factory tutorial series, and if this is the first video you are watching from me, I would highly recommend to check out the playlist on my channel that has many more Data Factory related videos. And now let's dive into Data Factory parameters and variables. Let's start with our setup here. We have two storage accounts, and in both of those storage accounts we have blob containers. In the first blob container we have two files. We have file1 underscore source.txt and file2 underscore source.txt, and we would like to copy these files to our second blob container and just change the underscore source into name to underscore sync. And because this is Data Factory series, we are going to use Data Factory pipeline to do this binary copy for us. First, we would have to create two datasets to Data Factory to describe the source files. Then we would have to create another two datasets into Data Factory to describe the sync files. After this, we can configure two copy activities to copy these files from the source blob container to the sync blob container. This setup is all good and fine and does the job. But if we would like to reduce the amount of Data Factory objects that are being used here, like the datasets, we can use Data Factory parameters to do that. Now let's go through how we would do it. So let's get rid of all of these datasets. And now let's add just one parameterized dataset describing the source, and let's do that same thing for the sync dataset. In this case, we don't hard code any file name values for these datasets. Instead, we add a parameter called file underscore name that can be used to input the file name dynamically for these datasets. And now we can decide which source file and which sync file names we are going to pass down for these datasets to configure the copy activity. And with this setup, both of our copy activities are actually using the same source dataset and same sync dataset, but with just different parameter values for those datasets. But there is actually a way to simplify this even more, and we can use just one copy activity to handle this whole pipeline. So we can get rid of these two copy activities and replace them with just one copy activity. In this case, we can use pipeline level parameters and pass them down to this pipeline and dynamically decide which source dataset we are going to copy to which sync dataset. So let's add source file name and sync file name as our pipeline level parameters to this pipeline. Now we can pass these parameters down to our pipeline, and from the pipeline we can pass these down to our copy activity and to the datasets. And now we can dynamically change the file that will be used as a source and the file that is used as a sync. And this way we can significantly reduce the amount of Data Factory objects like datasets that we have to create, and also the activities that we have to use. I understand that this can seem a bit confusing at first, but when we get to the Data Factory demo part of this video, then this will hopefully become a lot clearer how this parameterization and passing down those parameters works in action. Now let's take a look at different parameters that we have in the Data Factory. First, we could parameterize the linked service and, for example, parameterize the database that is being used on the SQL server. Then we have the dataset parameters that we just went through in the previous example, that we can, for example, parameterize the file name or even the blob container that is being used to fetch the data. Then we have the pipeline level parameters that we also covered in that previous example. So we can pass down some parameters for the pipeline when we are running it, and for example say that copy this file to this sync using those parameter values. Lastly, we have global parameters in Azure Data Factory. These are the parameters you can set at the Data Factory level, and they are available all over the Data Factory, so you can reference them anywhere you want. Next, let's cover the different data types that we have available for the parameters in Data Factory. First, we have the string type. This is basically your basic text parameter, so you can type some text to this parameter and give it as a value for it. Then we have integer type parameters. These are basically your whole numbers or negative numbers, basically 1, 2, 3 or -1, -2, -3 and so on. Then we have float values. These are your floating point values, meaning numbers with decimals. Then we have Boolean parameters. These are your true and false values. Then we have array type parameters, and this is basically your list type parameter in Data Factory, and you can use these for many cool things that we are gonna cover in the future. Then we have object type parameters, so you can pass down some object values as parameters. And if you're familiar with JSON objects, this basically means passing down JSON as parameter. And lastly, we have secure string parameter that will actually mask your values that you input to that parameter. Along with parameters, we also have variables in the Data Factory. Variables are similar to parameters, but the main difference is that these values are defined during the pipeline execution, and they are not passed down to the pipeline like parameters. Supported data types for variables are a bit more restricted than with parameters, so variables only support string, integer, boolean and array values. We also have quite a variety of system variables available in Data Factory. This could be your pipeline name or Data Factory name, to name a two that are available. The most important activity from the variable point of view in the Data Factory is the set variable activity. This is used for setting the variable values. Also, this allows setting pipeline return values that we are not going to cover in that much detail in this video, but basically pipeline return values would allow you to send a return value from a nested pipeline to a pipeline that is calling the nested pipeline. But this we will cover in much more detail in upcoming videos. Then we have an append variable activity, and this only supports array type variables, and with this you can append values in the array type variables, and this can come handy if you need to create array dynamically during the pipeline execution. Now we have covered the Azure Data Factory parameters and variables on a conceptual level. So next, let's open up our Azure portal and our Data Factory to see how these concepts work in action. Now we are in the Azure portal, and I have already created 2 blob containers for us to use in this demo. We have tutorial 5 source and tutorial 5 sync. To the tutorial 5 source container, I have already added 2 text files and added some random content inside those text files. The content in this case doesn't really matter, since we are doing binary copies and we are not caring about the data inside those files. And our sync container is still empty. And now we would like to copy some data over to this sync container using parameterized Data Factory pipeline. So let's open up our Data Factory. let's start by creating a new folder for our tutorial 5. Into this folder, let's create a new pipeline and name our pipeline according to our naming conventions. And then let's create a copy activity to this pipeline. Let's name our copy activity to copy data from source blob to sink blob. And now we would have to configure the source and the sink dataset for this copy activity. And now the goal here would be able to use this same copy activity to copy both of these files according to our pipeline parameters. So first, let's create a folder for our datasets called tutorial 5. Let's create our first datasets. Let's select Azure Blob Storage, and then let's select binary, and let's name our dataset according to our naming conventions. Then let's select our linked service that is pointing to our blob storage, and now let's go and find our container that we're going to use as a source, but let's not select any files here since we want to dynamically change the file name. And to this file name value, we do not want to hard code any file names. So we can open the parameters tab of this dataset. And to the parameters tab, let's create a new parameter called file name. And then we can go back to the connection tab and use this file name as a dynamic content for our file name here. We're not going to cover this dynamic content in that much detail in this video, but I will briefly explain that this dynamic content allows the use of dynamic values in the Data Factory. And in this dynamic content, we have also a lot of built-in functions that Data Factory offers us to build our dynamic content using those functions. But we will come back to this dynamic content in later videos. For now, it is enough for us to know that this dynamic content allows us to use parameters to replace the values in the Data Factory. Now we can select our dataset parameter called file_name that we just created. And now we can go back to our pipeline and select our dataset that we just created. And after selecting our dataset, we can see that our dataset has now a new property called file_name that we can use to pass down the value that we want for that dataset. In this case, we want to pass down the file name for this dataset. Next, we want to create a pipeline level parameter to this pipeline. So we can click anywhere in the empty space of the pipeline development view, which will take us to the pipeline level properties. Here we have the parameters. Let's create a new parameter for this pipeline. Let's call this source file name. And we want to have this parameter as string type, since we will be passing down string values that describe the file name to this pipeline. Now we can go back to our copy activity and select our source dataset and pass down this pipeline level parameter to our dataset. And the process what will happen here is that the parameter is defined on the pipeline level, then it is given as parameter to our dataset, then it will figure out dynamically the file it needs to fetch from the blob storage according to that parameter. And now we have configured the source dataset parameter correctly. So let's do the same operation with our sink dataset. So let's create our sink dataset. Let's select Azure Blob Storage and then the binary again, and let's name our dataset. And same thing here, and let's find our container, and in the sink container we don't have any files yet because we're gonna copy some files there. So okay, and let's create our dataset, and again let's create a new parameter called file_name for this as well, and let's pass it to our file name in our file path. And now let's go back to our pipeline and let's configure this sink dataset here, and it has also the parameter value here. So let's go to the pipeline parameters and let's define new pipeline level parameter and call this sink_file_name. And now we would like to pass down this to our sink dataset. So let's go there and use the dynamic content to pass down the sink file name parameter for this dataset. Okay, so now we have configured everything for this copy activity. We have the pipeline level parameters, and now we can debug our pipeline in order to see what happens. And now when we click the debug button, the Data Factory will actually prompt us with this pipeline parameter view that will ask values for these parameters that we are using for this pipeline. So for the source file name, we want to first input the file one_source.txt, and then the sink file name, we're going to input file one_sync.txt. So we will be copying the file one to our sink and just renaming the source to sink in that file name. And after we have defined those, we can click OK, so the debug run will start. And now our debug run is running. This should only take a couple of seconds to run, since we're only moving a few bytes of data from the blob storage to the same blob storage. And now our debug run is done, and we can check that files read was 1 and files written was 1. And now we can actually go to our sink container and see that we have a new file there. And we have here file_sync.txt. So according to this, everything worked fine and we were able to copy this file to our sink. Now let's go back to the data factory and let's repeat this same process, but now let's modify the parameters. And now we want to copy the file2_source.txt to our sink and name it file2_sync.txt. And let's click OK and start running our pipeline. Again, this should only take a couple of seconds, since the amount of data that is being moved is so small. And now our pipeline is already done. And let's check the log. Again, one file copied and one file written. So according to this, everything worked fine. And we can go back to our sink container and refresh the view and see that now we have there 2 files. So now we have copied successfully the both files to our sink container using the same data factory pipeline by just dynamically deciding which file we're going to copy. And now then we have tested that our fabulous pipeline works, we can go to the data factory and publish our changes, so it will save these pipelines and datasets to our data factory. Next, let's quickly check where we can find our global parameters for the data factory. So we can go to the Manage tab, and here we can find global parameters. And here we can define new global parameter for our data factory. As an example, let's define environment parameter for our data factory, and let's have that as a string type. As a value, we can add demo, since this is our demo environment for these tutorials. So let's add the global parameter called environment as a value demo to this data factory. Then we can go back to our data factory pipeline and click our copy data and check our dataset parameters. And here we can see that now we have a global parameter called environment available. And if we would choose this to be the file name, it would set it as to be demo, like we defined in the global parameters. But since we don't have a file called demo, there is no point for us to assign that value to this pipeline. So let's just click cancel. Next, we can check out the linked service parameters. So let's go back to our Manage tab, open linked services, and let's open our blob storage linked service. And here we can also find parameters. Here we can, for example, define as an example ls_parameter and have it set. And then let's go back to our pipeline and see how this linked service parameter would behave. Here we can see that our activity does not have a new parameter defined here in the dataset properties. But if we open the dataset itself, here we can see that we have linked service properties, and here we can define the value for the linked service parameter. And here we can basically type whatever we want, because that parameter is not really used anywhere in the linked service, so it doesn't really matter what we input here. Also, even though this linked service parameter is not available in the dataset properties in the pipeline level, there is a way for us to get that show up there. And this will require us to go to the dataset parameters and define a new parameter there. And then we can use this parameter to pass down values for this linked service parameter in this dataset. So now if we go back to our pipeline and select our copy activity, we can see that this dataset has now a new parameter, that is the ls_parameter that we just created, that we can use to pass down values from the pipeline to that linked service. I hope this example highlights that we can have these parameters on many different levels on Data Factory and use these parameters to pass down values from one Data Factory object to another. So here we are basically passing down parameters from the pipeline level to dataset level to linked service level, and the same value would go through this whole process. And in these examples, we have just scratched the surface what we can do with the Data Factory's dynamic content and parameters, that we can build way more dynamical pipelines in the later videos. So this video is just a small stepping stone for a lot of cool stuff that we're gonna do in upcoming videos. Now let's do a quick demo to demonstrate how the variables work in the Data Factory. Let's start by creating a new pipeline for our second demo in this video. Let's first name our pipeline. Then let's navigate to our activities and open the General Activities tab. And here we can find the set variable activity. Let's add one set variable activity to our pipeline. This set variable activity allows us to set pipeline variable values. But here, if we open the Settings tab, we can see that we have no variables available. This means that our pipeline doesn't have any variables created. So we have to create one. Now again, like with the parameters, let's click somewhere in our pipeline development view to open pipeline settings, and then we can open the variables tab here. Let's create a variable called variable1, and then we can check all the different data types that are available for the variable, but for now we want to just use the string type for our variable. Next we can go to our set variable, and now we can open the settings, and now we have the variable 1 available. Now we can add some value to our variable 1. We can open the dynamic content tab and see what options we have available here. In the parameters, we only have the global parameter available since we haven't defined any parameters for this pipeline, but we have defined the global parameter to this data factory in the previous demo that we did. Then we have also a bunch of system variables that we can use to assign values for this variable. We have, for example, the data factory name, pipeline group ID, pipeline run ID, and so on. And for the demonstration purposes, we're going to assign the data factory name to this variable. Next, let's create the second variable to this pipeline. Let's call that variable2. And then let's add a second set variable activity. And go to the settings tab and select variable2, and now let's configure some value for this. And now let's just write some random text to this value section of this set variable activity to assign this random text to this variable2 as value. And then we can create a third variable to this pipeline. Let's call that variable3. By the way, this variable 1, 2, and 3 is not very good naming convention for variables, so I'm just using this for illustration purposes, but please try to come up with more descriptive names to your variables than these. And to this third variable, we're actually going to assign a pipeline parameter value. So let's go to pipeline parameters and let's create a new parameter. Let's call this parameter 1. And let's assign a default value for this parameter so we can see what that does. So let's just write some text there. And this text we will assign to our variable 3. So let's go to our variable 3, select the dynamic content and select parameter 1 as value for this variable. Now we have set up the 3 variables to this pipeline. So we can click debug, and as we can see, our default value for this parameter is already available in our parameters, so we do not have to change it. Of course, we could replace this default value with anything we want at this stage, but now we can go with just the parameter default value. So let's run our pipeline. And our pipeline finishes immediately because we have just some set variable activities here. And now we can see the outputs of those set variable activities. Our variable 1 output is our data factory name, like we defined. And our variable 2 value is some text here that we wrote to the value field in that set variable activity. And our third variable value is the parameter value that we wrote to the parameter default value. So everything worked fine, and we have defined some values for our variables. Now that we could actually do that, we could drag a copy data activity to this pipeline and use these variable values in that copy activity, because these variables have been defined in this pipeline logical flow before this copy activity. As you can see, we can open the variables tab in this copy activity using the dynamic content and see that we have variables available here that we have created. However, we do not really want to add any copy activities to this pipeline, so let's just remove that copy activity for now. And now I have demonstrated to you how you can use set variable activities to set values to your pipeline variables. This is also just a scratch to the surface what comes to the variables, and in upcoming videos we are going to use variables in way more complex situations to build way more dynamical and flexible pipelines to orchestrate and run your data pipeline flows in the Data Factory. Today's topic is going to be dynamic expressions in Data Factory. We already touched upon this topic in the previous video where I covered Data Factory parameters and variables. So if you haven't seen that video, I would highly recommend you watch that before watching this one. Link to that video can be found in the description. And now, without further ado, let's jump into today's subject. Today we will start things off in the Data Factory. I will create here one pipeline that I will use to demonstrate where the dynamic content can be found in the pipeline view. So let's create that pipeline. And let's add one copy data activity to this pipeline. This pipeline is not going to serve any practical purposes in this video, so we are not going to focus on this pipeline that much. We are going to now open up the source tab in the copy data activity and just select some dataset that we created in our previous videos. After selecting that, we can start hovering our mouse over these different input fields that we have in this copy data activity source tab. We can see that this add dynamic content will appear under those fields when we hover our mouse over those. This would allow us to add dynamic content into those input fields. As you can see, this dynamic content can be found in almost any input field that we have in this activity. We can also open up the sync tab and also select the dataset there. And we can see the same thing happening here, that when we hover our mouse over the input fields, we can see that add dynamic content pop up here as well. Now we can go to the settings tab and we can see that also here in many fields we have that dynamic content available. And now let's go back to the source tab and let's open the dynamic content for our file name. We can see that this will open a pipeline expression builder window. And this would allow us to define some dynamic content to this input field, meaning that instead of hard coding values, we could dynamically come up with values based on our pipeline logic. And this would allow us to build way more dynamic pipelines. As we can see, we have here one parameter that is the global parameter environment that we defined in the previous video available, and we could use that here to input the value of that environment parameter to this file name dynamically. I already covered passing these parameters dynamically in the previous video, so we are not going to focus on these in this video. Instead, we can open the Functions tab. This is the tab that we are going to focus on today, since the Variables tab we already covered in our previous video. When we open this Functions tab, we can see that we have here many groups of functions. We have collection functions, conversion functions, date functions, logical functions, math functions, and string functions. And we could expand all of these so we can see that the amount of functions we have available here in the Data Factory is quite large. Today we're actually going to cover two of these functions in more detail, but when you get the grasp of the Data Factory expression language, then using any of these functions would be easy. Now let's take a look at Data Factory's expression language in more detail and cover a few functions as examples. In my opinion, using Data Factory's expression language is a bit similar to using Excel functions. So if you are comfortable using those, then you should get hang of these quite fast. So for using these Data Factory's functions and expressions, you don't need to be any hardcore programmer to understand these. You just need to understand some basic programming principles. Now let's cover two very commonly used functions in way more detail. Let's start with the concat function. This is a pretty simple function in the Data Factory that will combine two or more strings together. And the basic syntax for this is that we have the concat, then open parentheses, and then we have a bunch of strings separated by commas, and then we have closing parentheses. So basically this function takes in a bunch of strings and then returns those strings combined into one string. And now let's see how this function would operate in action. In this example, we have three different input strings that we're going to give to our concat functions. First, we have the input string 1, which is going to be file. Then we have input string 2, which is going to be _1. And then we have input string 3 that is going to be .txt. Then we are going to input these to our concat functions, and we start with the @ sign. Always the Data Factory expressions start with the @ sign, and then we have the concat, open parentheses, then we have our input string 1, and then we have a comma and our input string 2, then other comma, and then our input string 3, and then closed parentheses. Also, these string values have to be in the single quotation marks so that Data Factory identifies them as string values. Then as an output from this function, we get file _1.txt. So this concat just concatenates these 3 input strings together. Pretty simple, right? Next, let's cover another function that is very commonly used in the Data Factory, and that is UTC now. This function will return the current timestamp in the UTC time zone. The syntax for this function is UTC now, open parentheses, then the optional format and the closed parentheses. And this format is optional, since if we don't specify it, we get this kind of a default ISO standard timestamp out of this function. But if we would want to format the timestamp in a different way, then we would have to specify the format. And I will show you in the upcoming examples how we could use this format to specify different kinds of timestamps. The return value of this timestamp is the current date and time, like described. Now let's have our first UTC now example. In this example, we are not going to pass any formats for our UTC now. So let's start our expression with the @ sign, like we have to do in the Data Factory, and then just add UTC now without any formats. Then output of this function will be a string value that will be our timestamp. And here we can see that we get this timestamp in this format that we have the year first in the green, then we have a dash, then we have 09, then another dash, and then 11. This is the current date when I'm recording this video. Then we have a T that separates the year, month, day from the hours, minutes, and seconds. After the T, we have hours, then we have colon, then we have minutes, then another colon, then we have seconds, and then period, and then fractions of a seconds. And then as last thing, we have a Z, which describes that this is a 0 time zone, meaning UTC timestamp. Next, let's cover another UTC now example. And in this example, we want to specify a format to our UTC now function. Let's specify a format to our UTC now function. First, in our format, we want to specify the year. So we want to be year to be first. So we specify the year as 3 Ys. This will tell the UTC now function that we want to add year here. Then we add 2 capital M's. This will be indicating that we want months here. Then we add 2 D's, and this will indicate that we want days here. And then we have T that will be separating our date from our hours and minutes and seconds. And after the T, we want capital H, and these will indicate that we want hours here. After those, we want 2 M's, and this will indicate that we want minutes here. And now take a note that lowercase m's means minutes and uppercase m's means months. Then as last thing, we want seconds, and we will specify SS there, and that will indicate that we want seconds there. And then we will add a Z to the end to indicate that this is a 0 time zone timestamp. And now let's pass this format to our function and have it in the single quotation marks that will indicate that it is a string. And after running our function, our output is going to be this more condensed format of the previous timestamp. Now in our last example, let's raise the complexity a bit. So let's now combine using the concat and UTC now function in the same expression. Let's start by defining our input string 1 for our concat function. It's going to be file underscore. Then our input string 2 is actually going to be the UTC now function with the format that we specified in the previous example. Then our input string 3 is going to be .txt. So now let's input these to our concat function. Let's start with the @ sign. And then we are going to have the file underscore as our first input string. After that, we are going to have the UTC now function with the specified format, and then we are going to have .txt. And now when this function will actually resolve, it will first resolve the UTC now in the middle, which will be resolving to that timestamp that we have defined. And then it will combine these strings together, so our output is going to be file underscore timestamp.txt. And this is a simple example how you can nest these functions in the Data Factory expression builder using the dynamic content. And you could actually get really wild here and start nesting a lot of functions inside each other and start to build a lot of complex logic in that express window. But the goal here is not to build the most complex logic, but to build the most simplest logic that does the trick, because we do not want to build overly complex pipelines, because maintaining those in the production environments could be a hassle. Now let's go back to the Data Factory and do a quick demo to see how these functions work in action. Now I'm going to show you a quick demo how to use the dynamic content expression builder and the functions in the Data Factory to build more dynamic pipelines. Let's start by creating a folder to our pipeline. Let's name that tutorial 6. Let's create a new pipeline. Let's name our pipeline according to our naming conventions, and let's add copy data activity to this pipeline. Let's also name our copy activity accordingly. And then let's create two datasets, one for our source and one for our sink. Let's first create a folder for our datasets called tutorial 6, and then create our first dataset. Let's select Azure Blob Storage, click continue. Then let's select binary, because we just want to use the binary copy and we are not caring about the file contents in this demo. And now I can show you that I have already created two containers for us to use in this demo to our blob storage. We have the tutorial 6 sink and tutorial 6 source. In the tutorial 6 source we already have one file, and I have just added some random text content to that file, because the content, like I said, doesn't matter in this demo. And our tutorial 6 sink is still empty. And now we would like to copy the data from our source to our sink. Let's name our source dataset, and now let's navigate to our blob and find our file there. Let's select that and let's click OK and create our dataset. And now we have configured our source dataset. Next, let's configure our sink dataset. Let's create a new dataset. Let's select Azure Blob Storage, again binary, and then let's name our dataset according to our naming conventions. Let's select the linked service, and then let's select our tutorial 6 sink. And in our sink we don't have any files to choose, so we can just move forward. And now we can go back to our pipeline and first configure the source and select the dataset that we just created. And then we can configure our sink and go there and also find the dataset that we just created. But for the sink dataset, we actually want to create a parameter that we can dynamically use to pass down values to this dataset. So let's go back to our sink dataset and let's create a parameter called file underscore name for this dataset. And then we can navigate the connection tab of this dataset and go to the file name and use add dynamic content functionality to open the pipeline expression builder. To this input field we only want to pass down the value that is coming out from our parameter file underscore name that we just created. So we will select that. Now we can go back to our pipeline and see that our sink dataset has a new parameter called file underscore name that we just created. Now we would like to dynamically define our sink dataset name. So let's open the dynamic content and our pipeline expression builder and navigate to functions. Let's first find our concat function. We have this convenient search bar here that we can use to find the concat function. And we can type the concat here and see that our concat function is here. And when we hover our mouse over the function, it gives this little piece of documentation for us to see how this function works and what is the return value of the function. You can use this as a quick reminder to you how the function works if you have forgotten. And we can actually click this concat function here and it will add it to the expression builder. Next, we want to define the inputs for our concat function. Our first input string is going to be file underscore name, so we will write file underscore name there in single quotation marks. And next, we would like to use UTC now function as our second input string here. So let's use the search functionality and find our UTC now function. After we have found our UTC now function, we can also click that and add it to our expression builder. For some reason, it doesn't add that function as camel cased like it should, so it gives us this slight warning that this function should be regarded or would be regarded as UTC now with capital N. But we can change that tiny detail there manually to get rid of that annoying yellow line there. Next, we would like to specify a format for our UTC now function. And we're going to use the same format that I showed you in the example that we covered in the previous section. So let's use this year, month, day, T, hours, minutes, seconds, and Z format and have that in the single quotation marks. So Data Factory identifies that as a string and not a function. Next, let's have our last input string, and before that, let's add a comma and then add single quotation mark and then add .txt. And here we have our expression that we will be using to dynamically come up with our sync file name when we run the copy data activity. So basically we are going to combine the file underscore name with our timestamp and then have .txt ending for our file. Now we have everything set and we can debug our run to see what happens. This run shouldn't take that long to run since we are just moving a tiny file from the blob storage to that same blob storage. And now it is done, and we can check the log that files read was 1 and files written was also 1. So it seems that everything worked fine. Now we can navigate to our sync container and see that we have a new file there. And in this file, we can see that now we have dynamically defined the timestamp there. So the timestamp will be different every time this pipeline runs, since the time is always going forward. So we can go back to the Data Factory and rerun our pipeline and see what happens. Let's click the debug again and let's start running this, and this should be done soon. And now it is done. And now we can go back to our sync, and now we can see that there are two files. This is the same file copied 2 times to this same sync container, but we have 2 files because the timestamp in the file is always different, so it won't overwrite the previous file. And this is something that you might want to do for some data transfers when you build Data Factory pipelines. But this is just a basic demo to demo how this dynamic content and building expressions work in the Data Factory, so that we can use these concepts in the upcoming videos to build actually more production-ready data pipelines with Data Factory. Today, we are going to check out the Data Factory conditionals. So, in other words, we are going to cover Data Factory, if condition, and switch activity. So, you can learn how to run your activities in your data pipelines based on a condition. To get most out of this video, I would like you to know the basics of Data Factory expression language. And if you don't know those, don't worry, I got you covered, since I just made a video on that, and the link can be found in the description. Now, let's dive into today's topic. Let's start with the if condition. In today's setup, we have a Data Factory pipeline. In that pipeline, we have activity 1 followed by activity 2. After the activity 2, we have activity 3 that we would like to run only on Sundays. And then we have activity 4 that we would like to run every other day than Sunday. So we don't want to run these activities on the same day. So how would we do this in Data Factory? Of course, we can wrap these activities to if condition. That is an activity that will wrap around other activities and execute them based on condition. And this will handle our situation at hand. Now let's check out in more detail how if condition works. And here we have the if condition activity as it can be seen in the Data Factory UI. First, we have to define the condition expression using Data Factory's expression language. This expression has to resolve into Boolean value, meaning true or false. In the if condition, we have 2 branches. These 2 branches correspond to 2 Boolean values that we have, so true or false. In those branches, we can define some actions, meaning activities that we want to run. So basically, we define the activities that we want to run when the expression resolves to true, and the activities that will run when the expression resolves to false. Then finally, when this if condition is executed in the pipeline execution, if condition will first evaluate the expression value, and if it's true, it will run the actions in the true branch, and if it's false, it will execute the actions in the false branch. Now let's check out in a bit more detail how this if condition expression evaluation works. Let's start with our pipeline description. Our pipeline logic is that every Sunday we want to fetch all 30 tables from the source. Otherwise, we want to only fetch the 5 tables that are needed daily. Our run schedule for our pipeline is going to be every day at 5 AM UTC time. And here we have our if condition block. In this block we have those 2 branches, true branch and false branch. In the true branch we have that copy 30 tables actions, and in the false branch we have copy 5 tables actions. Then we have to define the if condition expression. I have written an expression here that will check that if the day of the week is Sunday, it will resolve to true value. How this expression works, it will start from the innermost expression, which is UTC now, and this UTC now function will result into the current timestamp. Then we have the day of the week function that encapsulates that UTC now function, and this will return the index value of the date, meaning that the Sunday will be the index 0 and the Monday will be the index 1 and so on. So if this day of the week function results to 0, the equals function will result to true because 0 equals 0, and this will give us a true value for this. If the day of the week function evaluates to any other value than 0, then we get a false value, and then we get a false value as return value from this equals function. And based on this result, we will decide to which branch we are going to go in this if condition. Now let's imagine that we are running this pipeline on 17th of September 2023, which is Sunday. Then this if condition will evaluate to true, which will mean that we are going to copy all those 30 tables from the source. Now let's add one day to our run date, which is then 18th of September 2023, which is Monday, and then this if condition expression will evaluate to false, which means that we are only gonna copy those 5 tables from the source. And of course you could use any other expression in the if condition expression. The only limiting factor is that the expression has to eventually result to Boolean value, meaning true or false. Now we should have a basic understanding how if condition works. So next, let's go to Data Factory and see how this activity works in action. Now we're in the Data Factory. Let's start by creating a new folder for our tutorial 007. Then let's create new pipeline to this folder. Let's name our pipeline according to our naming convention. And now let's add if condition activity to this pipeline. Let's name our if condition activity to if Sunday, which means that if Sunday we want to evaluate the true value. Let's also add set variable activity to make this example a little bit easier to understand. And then let's create a new variable called current timestamp. And then we want to set the value for this variable in our set variable activity. And we want to use the expression language to set this variable value to UTC now, which is the current timestamp in the UTC time zone. And now let's also name our set variable activity to set current timestamp to keep things understandable here. And after this, we are ready to start building our if condition expression. Let's start by opening up the dynamic content for our expression. Let's first have equals function there, and then as a first equal, and then as first value we want to have 0, which indicates that it's Sunday, and then we want to have the day of the week function, and then we want to use the variable current timestamp in that day of the week function to check if the current timestamp is Sunday. And now our function is ready, and this function will result to true value whenever the day of the week is Sunday. And now we can define some actions to our branches. I will be just using wait activities in these branches because the goal of this demo is not to demo how to copy some data from some source to somewhere, but to demonstrate that how the if activity works. So we can just imagine that those wait activities could be a bunch of complicated logic. To the true branch I will add one wait activity and rename it as Sunday, and to the false branch I will add a wait activity and rename it as not Sunday, so we can see to which branch we end up when we execute this pipeline. And now we should have everything ready here, so we can click the debug button and start running our pipeline. Our pipeline already completed, and now we can check how the execution went. First, we can see that set current timestamp evaluated to 17th of September 2023, which is Sunday. And as you can see, then our if condition resulted us going to the true branch, meaning that it was Sunday. Now we can change things a bit and add some days to our timestamp using add days function. So let's add 1 day to our UTC now timestamp. And now when we debug this run, we should end up to the not Sunday branch. Let's see what happens. Our pipeline ran, and we can see that now our timestamp evaluated to 18th of September 2023, which is Monday. And as a result, our if condition went to the false branch, meaning not Sunday. So everything worked correctly. Last thing that I would like to point out about the if condition activity, that is that we cannot nest these if condition activities on top of each other. So we cannot have another if condition activity inside another if condition activity. As you can see, it is not possible to drag here another if condition activity. If we would like to have two if condition activities inside one another, we would actually have to create a new pipeline and have that if condition activity inside that pipeline and run that pipeline inside this upper level if condition activity. So this is quite a bad limitation in the Data Factory. Now we have covered if activity in Data Factory. So next, let's cover its brother, switch activity. Now let's cover switch activity in more detail. In our setup, we have a Data Factory pipeline. In that pipeline, we have activity 1 followed by activity 2. After the second activity, we have activity 3 that we would like to run when we have CSV files coming in. Then we have activity 4 that we would like to run when we have XML files coming in. And then we have activity 5 and we would like to run this activity when we have JSON files coming in. So we wouldn't want to run these activities at the same time. Instead, we would like to run them based on the file type that we have currently coming in the data pipeline. So how we would do this in the Data Factory? We could wrap these in the switch activity. So meaning that based on the file type, we would execute these different activities. Now let's check out in more detail how the switch works. Here we have the switch condition activity as it can be seen in the Data Factory UI. First, we have to define the selector expression for the switch activity. This means that we have to use Data Factory's expression language and define an expression that will resolve to a string value rather than Boolean value like with the if condition. Then we define some cases to this switch activity that are compared to the string value that is coming from the selector expression. And we can create multiple cases to the switch activity. Then we define some actions to these cases. Like with the if condition, we add some activities inside those case blocks. And the activities are executed when the specific case is met. Finally, when the pipeline is being executed, the switch activity will first evaluate the selector expression. Depending on the result of the evaluation, it executes the activities in the corresponding case. If none of those cases match, it uses the default case. Now let's check out in more detail how the switch evaluation works. Let's first cover our pipeline description. Our pipeline logic is that incoming file can be end with .csv, .json or .xml, and we have to process based on the file type. If the file ending is not any of those three, then we would like to throw an error message. And here we have our switch activity. In that activity, we have 4 different cases. First, we have the default case, which is the error case when none of the cases are matched. Then we have the CSV case, and we copy the CSV file when our file ending is .csv. Then we have JSON case, and we copy JSON file when our file ending is .json. And then we have the XML case, and we copy XML files when our file type is .xml. Like I described previously, we have to start by defining the switch expression for our switch activity. Here I have defined the expression that will basically check what is the ending of the file. So what this function does, it will get the file name from the variable file_name and then split this based on the period into an array and then get the second index, meaning index 1, from that array, which should be the file ending. And based on this expression, we get the evaluation result that we then use to check which case will be run. And now let's test our switch logic here. Let's have a file name file1.csv incoming to this data pipeline. So first our switch expression evaluates, and it will evaluate to CSV, which will then run our CSV case and copy our CSV file. Now let's mix things up and change our file name to file1.txt. Our switch expression runs and it will evaluate to txt, and this is not matching with any of our cases, so it goes to the default case, meaning it results to an error message. And again, this is just the one example how to use the switch expression, and we could write any expression to this switch expression field that will eventually result to a string value that we can then compare to our cases. Now we have covered the basics of switch activity. So next, let's jump into Data Factory and see how this activity works in action. Now we're back in the Data Factory. Let's create a new pipeline for our second demo in this video. Let's name our pipeline according to our naming convention, and now let's add a switch activity to this pipeline. Also, let's name our switch activity and let's name it as switch based on file ending, meaning that we want to run different cases based on the file type. And when we open the activities tab of this switch condition, we can see that we already have a default case defined. And like I described, the default case is the case when the expression evaluation doesn't match with any of our cases, then it will go to the default case. Now let's define 3 more cases to this switch activity. And let's name our first case to CSV, and our second case to JSON, and our third case to XML. And these are actually the strings that will be then used to compare to the expression result. So meaning if our expression result is going to be CSV, then the CSV branch is going to be used. Now let's define a new variable to this pipeline to keep things more understandable here. Let's name our variable as file_name. Then let's add set variable activity to this pipeline, and let's name this set file_name. Let's go to the settings tab of this set variable activity and let's set our file name, and let's hardcode value file1.csv to the value field. And like we did with the if condition, let's just add a bunch of wait activities to these branches so we can see which branch ran when we evaluated the expression. To the default branch, let's add wait activity and call it error, and then to the CSV, let's add wait activity and call it CSV, and to JSON, we call the wait activity as JSON, and to XML branch, you can guess it, we add a wait activity and call it XML. And now we can define the expression to our switch activity. And we are going to use the same expression that I went through in the theory section of the switch part of the video. So we are going to add split, and then we are going to add our variable file name, and then we are going to split this variable file_name from the period, and then we are going to take the second index, meaning index 1 of the array that will result from split activity, meaning the file ending. And now we are all set here, so we can click the debug button and see what happens. And the run succeeds immediately, so we configured everything fine, and we can see that our file_name variable was file1.csv, and this evaluates our switch expression to CSV, and it means that our CSV wait activity was run. So everything went fine from our perspective. Now let's change our file name to file1.xml and let's debug. And now we can see that we ended up to the XML branch. And now let's try changing our file ending to .txt, and now let's debug that. And now we can see that since we didn't match any of the cases, we went to the default branch of the switch activity, which ended up running our error wait activity. And as a last thing here, I would like to point you out the same thing that I with the if condition, that we cannot nest 2 switch activities on top of each other. Also, we cannot nest if conditions and switch activities to each other. So basically, if we would want to nest them, we would have to create new pipelines that encapsulates those activities. And now we are starting to step into more intermediate territory, since in today's video I'm going to show you how you can bulk load multiple different files from the blob storage to Azure SQL database using Foreach Activity. I will first start by explaining how the Foreach Activity works, and then show you an actual demo how you can use it to to build your own bulk loading data pipelines in Data Factory. To get most out of this video, you should be already familiar with Data Factory's parameters and dynamic content, which I have already covered in the previous videos. So if you need to refresh your memory on those, check out the links in the description. And now, let's get started with the Foreach activity. Let's start by imagining a situation that we have a storage account. In that storage account, we have a CSV file. Then we have Azure SQL database, and in that database, we have a database table. And now we would like to copy the contents of that CSV file into that table. Of course, we can use Data Factory pipeline to do this copy and add copy activity to that pipeline. This setup will get this job done very easily. But what if we have 20 CSV files with varying columns and then we have 20 SQL tables corresponding to those CSV files? And now we would need to add 20 copy activities to our pipeline to handle this situation. As you probably realize, building this will become very inconvenient fast when we have a lot of files coming in and we need to write them to the corresponding tables. But we have a solution for this. We can wrap this copy activity into Foreach activity and then only have one copy activity that we will loop through several times, in this case 20 times. Now let's check out in more detail how this Foreach activity works in the Data Factory. Foreach activity in the Data Factory is another control activity like the conditional activities that we covered in the previous video. And here we can see how the Foreach looks in the Data Factory UI. The Foreach takes in an array of items that is basically a list of items and loops through that list, executing all the activities inside the Foreach for those items. Here I have an example how this kind of an array would look like that we could pass down to the Foreach activity. In this example I have just two files or strings representing files in the array. Almost all activities can be added inside the Foreach activity, but with some limitations, like that we cannot add another Foreach activity inside another Foreach activity. During execution, the Foreach activity will run all the activities for every item in the list. So basically, if we have a list of 2 items, the Foreach activity will execute those activities 2 times, and if we have a list of 100 items, the Foreach activity will execute those activities 100 times. Now let's check out how the Foreach logic works. Here we have our Foreach activity. Inside that activity we have another activity that we would like to execute as part of our Foreach logic here. Then we have our array of items. In this case we have 3 items that we are going to pass down to our Foreach activity. The values in this array could be any data type that are supported in the Data Factory. So basically we could have an array of strings or maybe array of integers, or in some cases we could even have an array of objects that we could pass down to the Foreach activity. In this case I'm just representing the items as item 1, item 2, item 3 to simplify this example. Inside the activities in the Foreach activity we are going to reference these items with the reference @item. This will fetch the current item in the loop from the list of items that we are running in the Foreach activity. So during the iteration 1 of our Foreach activity, this @item reference will fetch item 1 for our array and use that value in our activities. And after we have executed all the activities in the Foreach activity, we start over and now we have again the item reference, but since this is the iteration number 2, we are going to now fetch the item 2 from our list using the @item reference. And after our second iteration is done, then we have the iteration 3, and then we are going to again use the @item reference and fetch the item 3 from our list. And this is the last iteration, so after we are done executing all the activities for this iteration, then we are ready to continue forward from the Foreach activity. Now we have covered the basics of the Foreach activity. Next, I will open up the Data Factory and show a demo how you can use the Foreach activity to build your own bulk loading data pipelines. Before jumping into Data Factory, I will use this animation to illustrate to you what we are going to build here. We start by having a storage account. In that storage account we have 2 CSV files with different column names, and then we have Azure SQL database. In that database we have corresponding tables for those CSV files. Then we are going to build a Data Factory pipeline to handle the copy from the storage account to Azure SQL database. For this, we are going to use the Foreach activity. In that activity, we are going to have a copy activity. Then we are going to set the pipeline parameters and have our file list there. So our CSV files are going to be animals and movies. Then we are going to pass down these parameters to our Foreach activity and use the reference pipeline parameters file list to be able to fetch these parameters to our item list. Now we can jump into Data Factory and set up this first part of this demo in there. Now we are in the Data Factory. I will open the storage account to show you that I have already created a tutorial 8 source folder where I have those CSV files. In those CSV files, I have added some data into them. In the animal files, we have 3 rows and the header, and in the movies files, we have also 3 rows and the header. Then we can open the SQL Server Management Studio and check out our database. In the database, we don't actually have those 2 tables yet. So we are going to use the Data Factory to create those tables for during the copy activity. And I will show how that's done later in this video. But now we want to create a database schema where we are going to add those 2 tables. So let's use create schema statement and create tutorial 8 sync schema. And now we can head back to the Data Factory. And let's first create a new folder for our pipeline. Let's call this tutorial 8. And now let's add a pipeline to our tutorial 8 folder, and let's name our pipeline according to our naming conventions. Then we want to add our pipeline parameters. So let's create a parameter called file_list and change the type to an array. And as a default value, I will add the list that has 2 strings, animals and movies. Next, let's add our Foreach activity to this pipeline, which can be found under iterations and conditionals. Now let's name our Foreach activity to for each item in the file_list. Now let's open the settings tab of our Foreach activity. As we can see, we have 3 possible settings here that we can configure. First, we have the sequential setting, meaning that if we would tap this setting on, it would run our iterations after one another and not in parallel. If we do not tap this, the Foreach will run our iterations in parallel to each other. And then we have the batch count setting. This setting is used to control how many parallel executions we have running at the same time if we are not using the sequential option. For now, we are not going to touch the sequential or the batch count setting for this demo, but it is mandatory to configure the items for our Foreach activity. And for our items, we want to use the parameter file_list to as items to this Foreach activity and loop through that list. Then we want to add copy data activity inside this Foreach activity, and let's name our copy data activity to copy data from blob to SQLDB. And now we have configured the first part of our solution. Next, let's open up the presentation again and let's see what we are going to configure next. The next step is to configure the datasets for our source and do our sync. Let's start with the source dataset, and then let's create the sync dataset. Then we are going to create a parameter for our source dataset and also a parameter to our sync dataset. Then we are going to use the item reference to reference the item in our list. For the source dataset, we are going to actually also add a concat function to be able to add .csv ending to our file name. And for our sync dataset, it is enough just to use the item reference, since we are not going to add any prefixes or suffixes to our table names. And after this, we have configured everything in order to copy those 2 CSV files from the storage account to SQL database. So let's go back to the Data Factory and configure these things there. Let's start with the source dataset configuration. Let's create a new folder for our datasets called tutorial 8. Let's create a new dataset. Let's select Azure Blob Storage, and then we want to select delimited text since we have CSV files, and let's name our dataset, and then let's select our blob storage. Then we want to select our container, and then we can click OK. Next, let's configure the file name parameter for our dataset, and then let's use that file name parameter in our file path for the dataset in the file name part of the path. Let's go back to our pipeline and let's select our newly created dataset as our source dataset. And as we can see, now we have the dataset parameter available here in the copy activity. And since we have those .csv endings in our files and in our file list parameter we don't have those, we need to add them dynamically to this parameter. So we're going to just use the quick concat function here to add that .csv ending to our file names. And of course use the item reference to reference the actual file name in the list that we're passing down to the Foreach activity. Next, let's create our sync dataset. And now we want to search for SQL database. Let's select Azure SQL database and let's name our dataset according to our naming conventions. And let's select our database from the linked service list. Since we have only one there, it is easy to pick. And let's leave the table name empty for now. And let's click OK. And now let's add table name parameter to this dataset, and let's use that parameter to replace our table name. And to keep things simple, let's just hard code the schema name that we created in the beginning of this demo to our schema name field. So it is tutorial 8 sync. Now let's choose this dataset to be our sync dataset in our copy activity, and let's configure the table name to use the item from our item list that we are passing down to the Foreach activity. So basically our dataset name or the table name is going to be animals or movies, depending on the iteration that we are running in the Foreach activity. And as you can remember, we didn't have those tables ready in the SQL database. So we have the Data Factory option to create those tables. So let's choose the auto create table in the table option. And now we have configured everything and we are ready to run this pipeline. But let's go first back to the presentation so I can show you what will happen when we run this pipeline. When the pipeline execution begins, we are going to pass down our pipeline level parameters to our Foreach activity as items because we have the pipeline parameters referenced there. Then our first iteration of our Foreach activity begins. And in the first iteration we are processing the animals file. So we are going to pass down the animal string from our list to our dataset parameters. So our source dataset parameter is going to be animals.csv and our sync dataset parameter is going to be just animals. Then these files will be passed down to our datasets and the pipeline will fetch the animals.csv from our storage account and write it to animals table in our Azure SQL database. After this copy has gone through, we are done with the first iteration of our Foreach loop. So we can start the second iteration, or these executions could be actually happening in parallel depending on our Foreach activity settings. And during our second iteration, we are just going to copy the movies.csv to the table called movies. And after this copy is done, we are done with our Foreach activity. Now let's see this same thing happen in practice in the Data Factory. So we can click the debug button and start debugging our Data Factory pipeline. Our debug run starts running and it should complete quite quickly. And now it is already done and we can see that our copy activities went through fine and some rows were written to the Azure SQL database. Now let's open up the Management Studio and let's see if we have those tables here. And as you can see, we have tutorial 8 sync animals table here and tutorial 8 sync movies table here. So it seems that the copy from the blob storage to Azure SQL database went through fine. Now let's check out that if we have some data in these tables. Let's first select everything from our animals tables and we can see that we have those 3 rows there. And then let's do the same thing for our movies table and we can also see that we have 3 rows there as well. So everything worked perfectly here. Last thing that I'm going to show you that we cannot actually nest another Foreach activity inside another Foreach activity. As you can see, we cannot add another Foreach activity into this Foreach activity. If we would need to add 2 activities on top of each other, we would actually have to create a new pipeline where we would add that other Foreach activity and then run a pipeline in this Foreach activity to run that other Foreach activity. So this is quite a limitation in the Data Factory, but that is how it is and we have to live with that limitation here. Today our topic is going to be the Lookup Activity. Also in this video I will reveal to you why the Lookup Activity is one of the most important activities to learn in the Data Factory and what kind of cool things it allows you to do. But now let's dive into today's topic. Let's imagine a situation that we have a Data Factory pipeline and in that pipeline we have a copy activity. Then we have SQL database and in that database we have a configuration table and we would like to use the contents of this configuration table to instruct our copy activity to copy some data. How we would do this? Of course, we can use the lookup activity in the data factory and fetch the contents of that configuration table and have them available in our pipeline for our copy activity to use them. Now let's take a closer look how the lookup activity works in the data factory. And there we can see how the lookup activity looks in the data factory UI. The lookup activity is an activity that can be used to retrieve content from a dataset. The activity has two options, either to retrieve first row from the dataset or retrieve all the rows from the dataset. However, there is a limitation how much data the lookup activity can actually return. And the limitations are that it can return maximum of 5,000 rows or maximum size of 4 megabytes. And after the lookup activity has run, then the contents of the lookup activity's output can be used in the following activities as dynamic content. Now let's take a look at how the inputs and outputs work with the lookup activity. In this example, let's have SQL database, and in that database, let's have a configuration table where we have two columns, source file and destination table. On our first row, the source file is currency.csv, and then our destination table is currency. Then on our second row, the source file is money.csv, and then the destination table is money. And we would like to use these values in our pipeline so that we would copy the contents of the currency.csv file to the currency table in the SQL database, and then we would copy the contents of the money.csv file to the money table in the SQL database. So this table is going to be the input for our lookup activity. And now let's also configure our lookup activity to only retrieve the first row. And now our lookup activity runs, and our output is going to be the first row of this table, meaning that we only get the source file and destination table of the first row in this table, meaning that it's currency.csv and currency. Also, these two values are wrapped in this object called first row. Next, let's run our lookup activity again, but now let's uncheck the first row only setting, and let's see how the output looks now. Our lookup activity runs, and now we can see that we get a different output from the lookup activity. We get the count, how many rows were retrieved, and then we get the value array, and in that array we have all the rows that were retrieved. So in this case we have two rows, so we get now both the currency and the money configuration out from the configuration table. Now we have the core understanding how lookup activity works and how it can be used. Next, let's open up the data factory and do a quick demo to demonstrate how the lookup activity works in action. Now we are in the data factory. Let's start by creating a new folder for our tutorial 9, and then let's create a pipeline to this folder. And let's name our pipeline according to our naming conventions. And now let's add lookup activity to this pipeline. And let's name our lookup activity to lookup SQL table. And now we would need to configure a dataset to our lookup activity to use. Let's first open up the SQL Server Management Studio and let's create a table that we can use in this demo. I have prepared this small SQL script that will create everything that we need for this tutorial. In this script, we first create a schema for the table called tutorial 9 configuration. Then we create a table to that schema called configuration table with two columns, source file and destination table. Then we insert two rows to that table, and then we just select the data, basically show the data how it looks. We can now run this script and see that now we have a table with two rows. We can also refresh our table list and we can see that we have the table available here in our SQL database. Now let's go back to the data factory and let's configure our dataset. Let's start by creating a new folder, tutorial 9, for our dataset, and then let's create a new dataset to that folder. Let's search for SQL database, and there we have it. Let's select that. Then let's name our dataset and let's pick the linked service that we're going to use for our dataset. Then we can find the table that we just created in the table list. And after that, we have configured our dataset correctly for this demo. And we can click OK. Let's just quickly preview the data to see that it looks all right. And it does, so everything should be set. Let's go back to our pipeline and let's use this tutorial 9 dataset as our source dataset for our lookup activity. During our first debug run, let's leave the first row only option as checked so we can see the output, what it does. Then we can click the debug button to debug our pipeline to see the outputs of the lookup activity. And now our pipeline debug has finished, and we can see that we have an output for our lookup activity. And here we can see that we have this output where we have the first row object, and in that object we have the source file and destination table. And in this case, since we only retrieve the first row, we only get the currency.csv and the currency values to our pipeline. Now let's uncheck that first row option and let's debug our run again. And now our run has finished, so let's check the outputs of our lookup activity now. We can see that now our output looks a bit different, since we have the count value there, meaning that we had 2 rows fetched from the database, and then we have the actual value array containing the values for those 2 rows. Now let's modify our pipeline a bit more so I can demonstrate to you how we can use the outputs of the lookup activity in the following activities. So let's add Foreach Activity to this pipeline, and let's add that after the lookup activity, so that in the logical flow the lookup activity will run before the Foreach Activity, so that we have the contents of the lookup activity or the outputs of the lookup activity available for our Foreach to use. And now let's add wait activity into this Foreach activity to just see how many times our Foreach activity runs. Let's also name our Foreach activity to for each row in configuration. Then we want to configure the items that will be iterated over in this Foreach activity, and we can open the dynamic contents for our items. And here we can see that the pipeline expression builder is already offering us the lookup activities outputs for us to use here. So we can see that we have a couple of different outputs that can be used here in the expression builder. And since we're using the Foreach activity, we are now interested in using the lookup activities output array. So that's the last one in our list, meaning the array of data from the lookup activity. So we choose that, and the pipeline expression builder adds the necessary expression to our dynamic content. Then we can click OK, and we're ready to debug our run. Let's click debug. Now our pipeline finished, and we can see in the output log that our lookup ran first, then our Foreach activity ran, and then we had 2 wait activities, meaning that our Foreach iterated over 2 times. So that is the same amount of rows that we had incoming from the lookup activity. Even though we didn't do anything with the lookup activity's actual contents inside that Foreach loop, you could imagine that we could have a copy activity or some other activities inside that Foreach activity that we would execute based on the contents that we retrieved from the lookup activity. And this is a very powerful setup in the Data Factory that would allow us to build this kind of a configuration-based and iterative pipelines. And we could basically fetch like 500 tables from our source system using this setup, using just 3 activities: the lookup activity, Foreach activity, and the copy activity. And then we would just have to build the configuration for that pipeline without building more pipelines or adding more activities to the pipeline. And in the upcoming videos, we are gonna come back to this topic, and I'm going to show you how to build this kind of more generalized and configurable pipelines, and what would be my recommended way of building these pipelines, and what kind of configuration I would like to use with these pipelines. We are checking out Get Metadata Activity that allows you to build some extra logic to your pipelines. And this activity is a great addition to your Data Factory toolbox. So without further ado, let's dive into today's topic. Let's imagine a situation that we have a storage account. In that storage account, we have a CSV file. Then we have a Data Factory pipeline. In that pipeline, we have a copy activity that would copy the contents of this CSV file. However, we have wrapped this copy activity to an if condition, and we would only like to run this copy activity if the CSV file has been modified during the past 24 hours. How we would do this? Of course, we can use the Get Metadata Activity in the Data Factory and fetch the last modified timestamp of the CSV file, and then have the logic in our if condition to only run the copy activity if the CSV file has been modified in the last 24 hours. Now let's digest this activity in a bit more detail, and here we can see how the Get Metadata Activity looks in the Data Factory UI. This is an activity that retrieves some metadata information about some dataset. There are 10 different types of metadata that are currently supported in the Data Factory, depending on the source or the link service for that dataset. The maximum size of output for this activity is 4 megabytes. The output of this activity can be used in the following activity as dynamic content, and this activity is a bit similar to the lookup activity that we covered in the previous video. Now let's take a look at what are the different metadata options that we have available for this activity, meaning what kind of metadata we can retrieve with this activity. First, we have the item name that will retrieve the item name, and then we have the item type that will return is the item file or folder. Then we have the size that will return the size of the item. Then we have created that will return the created timestamp of the file or folder. And then we have the last modified, and this will also return a timestamp telling the timestamp when the file or folder was last modified. Then we have the child items that will return all the files and folders inside a folder. Then we have content MD5 that will return the MD5 hash of the file. Then we have the structure that can be used to fetch the structure of a file or a table in a relational database. Then we have a column count that will return the column count of a file or a table. And then lastly, we have the exist that will check whether this file or table exists. And exists will return a Boolean value, meaning true or false. Now let's take a look at a couple of these options and what kind of outputs they would yield in the data factory. Let's have a storage account. In that storage account, let's have a CSV file and call that azure.csv. And then we are going to have a get metadata activity in our data factory pipeline. And let's first have the option of the get metadata activity set to last modified. And now when our get metadata activity runs, we can see that the get metadata activity will output the last modified timestamp of that file. Now let's change our get metadata activity option to exist, and let's run our get metadata activity again. And now we can see that our return value is a Boolean value, and it is now true since our file is there and exists. If our file wouldn't exist, the get metadata wouldn't throw an error, but it would return false. Lastly, let's set our option to structure. And let's see what kind of output our get metadata activity now yields when it runs. Now we can see after it ran, we get this structure array in the output, and it has all the columns and their data types that we have in the CSV file. We can see that we have there a column name, and the type of that is string, and then we have column type, and the type of the column is string, and then we have the column location, and the type of that is string as well, since we have the CSV file and everything is string there. And like with the lookup activity, the outputs of the get metadata activity would be now available to be used in the following activities as input and dynamic content. So this would allow us to build some extra logic to our pipeline based on the get metadata activity's outputs. Now we have core understanding how get metadata activity works. So next, let's open up the data factory and let's do a quick demo to demonstrate how this activity works in action. Now we are in the data factory. I will first show you that I've already created a container to our storage account that we can use in this demo. In this container tutorial 10 source, I have one file called azure.csv. And in this file, I have 4 columns and 5 rows, including the header that describe the Azure resources in this resource group that I'm currently using. Let's go back to the data factory and let's start by creating a new folder for our pipeline. Let's call this folder tutorial 10, and now let's create a pipeline to that folder and let's name our pipeline according to our naming conventions. Then let's add get metadata activity to this pipeline. Let's just name our get metadata activity as get metadata. And now let's create a new dataset that will point to that same file that I showed you earlier. Let's create a new folder for our dataset called tutorial 10. And now let's create a new dataset to that folder. Let's select Azure Blob Storage and let's select delimited text since we have a CSV file. Let's first name our dataset according to our naming conventions, and then let's pick the linked service for our dataset. And now let's navigate and find our file in the storage account. And now we are done with the dataset configuration and we can click OK. We can quickly preview the data that we can see that our configuration is correct and the data looks good, so everything is fine. Now we can go back to our pipeline and configure our get metadata activity to use this dataset as a source. And now from the field list option, we can select the metadata that we would like to retrieve. Let's first select the last modified. So we would like to retrieve the last modified timestamp of the file. Let's debug our pipeline. And now our pipeline has completed, and we can see that the output of our get metadata has this property called last modified, and it has the last modified timestamp for our file. Next, we could add a little bit more logic to this pipeline. Let's create a variable and call that var1, and let's add set variable activity after the get metadata activity and call that set var1, and then let's set the value for our var1 using the dynamic content. And as you can see, since we are running the set variable activity after the get metadata activity in the pipeline flow, the dynamic content has this activity output tab, and it already offers all the metadata items that can be retrieved with the get metadata activity. Since we are now fetching the last modified, we would like to set this value for this var1 to be last modified timestamp that will come out from the get metadata activity. Now we can debug our run again and see what happens. And after our run completed, we can check that we have now set the value for var1 to be the last modified timestamp of that file. And this is how you could use the outputs from the get metadata activities in the following activities. And today I will cover 5 essential best practices that you should consider when building your data factory pipelines. Let's start with the one practice that I have been already talking about in my past videos, and that is naming conventions. When building data pipelines in Data Factory or in any other tool, it is always a good practice to think about clear naming conventions for your development work items. In the case of Data Factory, it would be ideal to have some naming conventions for objects like pipelines, datasets, linked services, and triggers, so that you can keep things organized. Importance of naming conventions is really highlighted when you have multiple people developing pipelines to the same data factory. So let's keep things neat and organized, and let's have some naming conventions. Next best practice that I want to cover is the retry functionality in activities. By default, activities have 0 retries defined, meaning that if the activity fails, it won't try to run itself again, and it will throw an error message and in many cases fail the entire pipeline run. However, by setting retries to activities, we can get rid of multiple unnecessary failures in the data factory that could be happening due to some minor downtime with Azure or some external services that the activity is using. In my opinion, it is a good practice to set at least a couple of retries to activities, and depending on the case, adjust the retry interval to something other than 30 seconds. Our next best practice is also related to activities, and it is the timeout setting. By default, most activities have 12-hour timeout limit, and actually this default used to be 7 days, so in some older environments you might have some activities with this 7-day timeout limit. This timeout setting is something that data engineers would need to consider when building their data pipelines, since I have seen cases where activities have gotten stuck and they have been just running until they have reached their timeout limit. So it is always good to think what would be the maximum amount of time that a set activity could be actually running and adjust the timeout setting accordingly. Next up, we have one of the most overlooked but one of the most important settings in the data factory, and that is pipeline concurrency setting. This setting allows you to specify how many times a given pipeline can be running at the same time. I have seen many terrible things happen in production environments with pipelines that didn't have this setting defined. By default, one pipeline could be running multiple times in parallel, and in many cases, this is the situation that we don't want to happen. Of course, there are exceptions to this rule, like some generally used pipelines that are being used as sub-pipelines in many top-level pipelines. But as a good rule of thumb, in most cases you want this setting to be 1. And by setting it to 1, if an older run of the same pipeline is still running, when a new run is triggered, that pipeline will wait until the older run has been completed and start running directly after that. So next time when you fire up the data factory and start building new pipelines, really pay attention to this concurrency setting. Our 5th best practice is that you should utilize iterative logic when building your data factory pipelines. I'm not going to cover this topic in great detail in this video, since I have already made an in-depth video on this topic. And in this video, we're going to check out the pipeline return values. To get most out of this video, you should be already familiar with Data Factory's variables and dynamic content. If you are not familiar with those topics, please check out the links in the description where I have linked the 2 videos that I have made on those topics. Now let's go into today's topic, pipeline return values. What are those? If you are familiar with any programming languages like Python, you know that you can build functions there, and your functions can have return values. This is the similar concept to that. In this case, we can think about one pipeline as one function. So, when we are nesting pipelines on top of each other in Data Factory, we can send information from the lower level pipeline to the upper level master pipeline using return values. It is better if I don't try to explain this concept to you only verbally. So, let's fire up the Data Factory and I will show you how this concept works in practice. Now we are in the Data Factory. Let's start by first creating a new folder for our tutorial 12. And then let's create our first pipeline to this folder. Let's call this pipeline PL tutorial 12 demo 1 logic. And now let's add set variable activity to this pipeline. And let's call this activity set pipeline return values. I have already used this activity in many previous videos and used this to set pipeline variable values. But in this case, we want to set pipeline return values that can be also set with this activity. This can be done by opening up the settings tab and changing the variable type from pipeline variable to pipeline return value, which will then allow us to create return values for this pipeline. We can click New and this will add our first pipeline return value. Then we can open up the type menu and see that we have plenty of different data types to choose from for our pipeline return values. Types here are more or less the same that we have for pipeline parameters. We can try a few of these different types in this demo and let's create 3 pipeline return values. For our first value, we want to have the type as string, and for our second value, we want to have it as an expression, and for our third one, we want to have array as our pipeline return value. Next, we want to name our pipeline return values. Let's name our first pipeline return value as string underscore PRV, and PRV stands for pipeline return value. Then our second one as expression underscore PRV, and then our third one as array underscore PRV. For our string type value, we want to write some text. In this case, I will write here, this is string value. For our expression type return value, we want to add a dynamic expression. In this case, I will add UTC-now function that will return a timestamp to this expression. And lastly, for our array, let's add 3 strings. Let's write first, second, and third, so that our array will contain these 3 strings when it's returned. Now we have successfully configured this lower level pipeline, and we can click debug and see that it runs fine. And it already finished, and we can see that our set variable returns some values, and we can see all of our pipeline return values there. Next, let's create another pipeline, and this time let's call this PL tutorial 12 demo 1 master. And to this pipeline, we want to add execute pipeline activity, and let's call this activity as demo 1 logic. And then we can open up the settings tab and find our demo 1 logic pipeline. So now our setup here in the Data Factory is that we have nested these 2 pipelines on top of each other. So we have the master pipeline that is calling our logic pipeline. Then I want to add 3 set variable activities to this pipeline so I can demonstrate how the return values are returned from the lower level pipeline. And here it is key that these set variable activities are executed in the logic after the pipeline has executed, so that we first execute the logic pipeline and then we have the set variable activities in our pipeline after that. If we would have them before, we wouldn't have the return values available in our pipeline when the set variable activities execute. Next, we have to create 3 variables to this pipeline. I will create variable 1, variable 2, variable 3, and variable 1 and 2 can be strings, and then the last one have to be array. If you remember, we had the last return value as an array. Now let's open up the set variable 1 activity and let's open up the settings tab and let's set the value for variable 1. And here we want to use the dynamic content when setting up the variable value. When we open up the dynamic content, Data Factory is already offering us these demo1 logic pipeline activity outputs. We have here demo1 logic activity output, then we have demo1 logic pipeline return value, and the demo1 logic pipeline return value is the one that we want to use. So let's click that. And now we want to specify further which return value we want to fetch from the pipeline return values. Because this is the variable 1, I would like to fetch the string underscore PRV return value. So we can write it to the expression as the last object here. And now we should be done with the variable 1 configuration. And we can move on to the variable 2. And for the variable 2, the process is almost the same, except we want to select a different return value this time. For this one, we want to select the expression underscore PRV value, which will be our timestamp. And for our third variable, the process is more or less the same, but now we want to select the array underscore PRV value for this. And now we should be done with the configuration. So now we can debug our run and see what happens. So let's click the debug button. Our pipeline already finished. It ran the logic pipeline and then it executed the set variable activities. We can check what are the values for our variables after the execution. Our variable 1 value is this is string and this is correct. Then our variable 3 value is the array that we specified. And lastly, our variable 2 is the timestamp that is coming from the UTC-now function. So everything worked fine. And this is the way how you can use the pipeline return values in Data Factory and return some values from the lower level pipeline to the top level pipeline. This is actually a pretty new functionality, and I'm very happy that Data Factory team has added this, because previously when this was not available and there was a need to send information from a lower level pipeline to the upper level pipeline, you basically had to write it to some file and use lookup to retrieve those, and things got really messy really fast. So this is really cool functionality and I'm really happy to have this in the Data Factory. And in today's video, I'm going to cover configurable pipelines. This is a topic that is already building on top of the topics that I have covered in the previous videos, like Lookup Activity, Foreach Activity, and dynamic content. If you're not familiar with those topics, please check out the links in the description before watching this video. And now, what are configurable pipelines? In many cases, when we are building data integrations using Data Factory, we have steps that repeat from one process to another. For example, when we are moving binary files from staging area to data lake. This is a pretty common operation when building a data platform in Azure. For these processes that repeat from one pipeline to another, we can build generalized and iterative pipelines to Data Factory that use configuration files. And in this video, I'm going to show how that will happen. So now let's go to the presentation and I will show what we are going to build today. Today we are going to build configurable pipeline. In this setup we are going to have a Data Factory pipeline, and in that pipeline we are going to have a copy activity. This copy activity will just do some binary copies from the blob storage back to that same blob storage. We have wrapped that copy activity to a Foreach activity, so this will be a dynamic copy activity. However, today we are not going to pass down the instructions for our Foreach activity using Data Factory parameters. Instead, we are going to have a storage account. In that storage account, we are going to have a configuration file. This configuration file will contain all the necessary instructions that our copy activity needs in order to execute those binary copies. In order us to get that configuration content to our pipeline, we are going to use the Lookup Activity to fetch the contents of that JSON file and then pass them to our Foreach activity, which will then pass it down to our copy activity, which will then handle the copy. Now let's check out how that configuration file looks. Here we have one example how this configuration file could look. So basically in that configuration file we would have an array, and then we would have some objects in that array. In this case we are having two objects in array. In these objects, we have all the same properties. We have 4 properties. First, we have a property called source container that is saying the source container for our data. Then we have a source file name that is telling what is the source file name in that container. Then we have a sync container property that will tell the sync container for our copy activity. And last, we have the sync file name. So what will be the file name after the copy has executed? So in this case, we would be adding underscore copy to our file name, so we know that it has been copied over. And we are also copying it from the source container to the sync container. And in this case, this would happen for 2 files. In many similar Data Factory tutorials, people are using database tables for this configuration. Now I want to break it down quickly why I would say that using files is a better way to go than using database tables. My first point would be that version control process would be way more straightforward when using files, because files are more easily version controllable than database table data. Because for files, we can use, for example, AZ copy in our CI/CD pipelines in order us to copy them to the correct location in the next environment when we are deploying the solution. With database tables, deploying that data, it's a bit harder, but it's possible to do, but I would say it's more difficult and not so straightforward. Also, the storage account is a cheaper resource than Azure SQL database. And in many cases, your platform that you are building to Azure using Data Factory might not even contain Azure SQL database. Also, as a last point, using JSON allows us to use more complex data types like arrays and objects that are not supported in Azure SQL database. So we have a bit more data types to play around with when we are building our configurations. Next, let's jump to Data Factory and see how we would build this configurable pipeline. Now we are in the Data Factory. First, I will open up the storage account and show that I have already created 3 containers for this tutorial 13. One for the configuration, one for the source, and one for the sync. In the source container, we have 2 files, file1.txt and file2.txt. I have just added some random content to these files since the content doesn't matter, since we are just doing binary copies and we are not caring about the content. Our sync container is still empty since we're just going to copy those 2 files there, and we have not yet done the copy. In our configuration container, we have the configuration file for our pipeline. This configuration JSON file contains exactly the same content that I showed during the presentation part of this video. So we have there 2 objects, and those objects are going to give instructions for our copy activity in Data Factory and tell from which container and which file we are going to copy to which container to which file. In this configuration file, we have exactly the same contents that I already showed in the presentation part. So we have there 2 objects, and then we have there 4 properties in each object. And these properties will guide our copy activity to copy those files from our source container to our sync container and just add underscore copy to the file names. Next, let's go back to the Data Factory and start building our pipeline. First, let's create a folder for our tutorial 13. Then let's create a pipeline to that folder, and let's name our pipeline according to our naming conventions. Then we want to create a folder for our datasets, and then we want to create a new dataset to our folder. We are going to select Azure Blob Storage, and then we are going to select JSON as our format, since now we are creating a dataset for our configuration file. Now let's name our JSON file according to our naming conventions. Then we want to add some parameters for our JSON file to make this bit more dynamic. We're going to add parameters container and file name. Then we are going to use the dynamic content to populate the container and file name parts of our file path in this dataset. Next, we can add Lookup Activity to our pipeline, and let's name this lookup as Lookup Configuration, and then go to the Settings tab and let's find our JSON file that we just created. In this case, we want to untap the first row only setting, since we want to fetch all the contents that we have in this configuration file. If you remember, we had there 2 objects. If we would tap that first row only, we would only get 1 object out that configuration file, and this is not the case that we want. And we want also the lookup activity to return an array so we can iterate over that array. Next, we want to populate our datasets parameters. So for our container, it's going to be tutorial 13 configuration, and our file name is going to be our configuration file name. Now we can actually try to debug this pipeline and see that we are able to fetch the configuration contents. Our pipeline went through fine, and we can see that our lookup activity returned an array of 2 objects. And now we have basically fetched the contents of our configuration file to our pipeline, so we are able to use these contents in our following activities. Let's continue building our pipeline. Now we want to add a Foreach activity, and let's name our Foreach activity to Foreach configuration. Then we want to use the dynamic content to populate our Foreach activities item list that is expecting an array. So we will use the lookup activities output value to populate this, and this output value will contain the array that is coming out from the configuration file that I just showed to you. And then we can just add one wait activity to our Foreach activity to see that our pipeline execute this wait activity 2 times, since we have 2 objects that we are going to iterate over in this Foreach configuration loop. And we can click debug and see that this actually happens. And our pipeline already finished, and we can see that our wait activity ran 2 times. So it seems that our logic is working. Next, let's remove the wait activity and let's replace that with the copy data activity. Let's name our copy data activity to copy data from blob to blob. And now we would need to create a new dataset that we are going to use to copy the files from the blob storage back to that same blob storage. Let's again select Azure Blob Storage, and then let's select binary, and then let's name our binary dataset according to our naming conventions. Then we want to add some parameters for our dataset, since we are going to use the same dataset for our source and for our sink, but with different parameters. So let's add a container parameter and file name parameter. And again, let's use dynamic content to populate the corresponding sections in our file path with those parameters. Let's go back to our pipeline and let's configure our source, and let's select the dataset that we just created, and then let's configure our parameters. Let's start with the container configuration. If you remember from our Foreach video, we are going to use the item reference to reference the item in the current iteration. So we are going to add there @item, and then we are going to add .source container. So basically this will fetch the source container from the current configuration that is running in the loop. And then for our file name, we are going to use again @item, and then we are going to use the source file name part of our configuration. Then we're going to configure our sink. The process is more or less the same here, but we are going to now use the sink configurations. So for our container, we are going to use the sink container, and then for our file name, we are going to use the sink file name for our file name parameter. So now we have configured the sink and source correctly. We can go back to our pipeline level, and I can one more time to show you the outputs of our lookup configuration activity so you would understand what happens there. So basically we have there that array that we are passing down to our Foreach activity, and in that array we have 2 objects. In that object we have those properties that I just defined to the source and to the sink. So when we are running that Foreach activity, the @item reference will fetch the source container and source file name from this current iteration to that copy activities source part. And then the same process will happen to our sink part, but using these sink configurations here. Now we're done with our pipeline, and we can click the debug button to see that it works as we expect. Our pipeline already finished, and we can see that we ran the lookup configuration, and after that we ran the Foreach configuration, and then we ran 2 times that copy data from blob to blob. Now we can go back to our storage account and check out our sink container and see that we have those 2 files there, but now we have added that _copy to that file name like we defined in the configuration. So it seems that everything worked fine and our pipeline works as it should. The last thing that I want to add is that we could make this pipeline even way more configurable by adding some parameters to this pipeline. And then by using those parameters, we could decide which configuration file to fetch. So we could use this same pipeline to fetch multiple different files using multiple different configurations. And today we are going to check out the script activity that is one of the most versatile activities in the Data Factory. Script activity allows you to execute SQL statements in different SQL databases. Currently, script activity supports 5 different SQL databases, and those databases are Azure SQL Database, Azure SQL Dedicated Pool aka SQL Data Warehouse, then it supports SQL Server Database, then Oracle Database, and finally Snowflake Database. Today I will use Azure SQL Database as an example and run SQL statements from the Data Factory using script activity to that database to demonstrate how the script activity works. So without further ado, let's jump into Data Factory and let's see how to use the script activity. Now we are in the Data Factory. Let's start by creating a new folder called Tutorial 14 for our pipeline. Then let's create a new pipeline to this folder called PL Tutorial 14 Demo 1 Script Activity. Then let's add a script activity to this pipeline. Next, we want to open up the settings tab of this script activity and configure the linked service that we are going to use for it. And in this case, we want to use the linked service that I have created to this Data Factory that is pointing to the SQL database that I have in the same resource group with this Data Factory. So let's select that. For this activity, we do not need to create any datasets, since we are just sending some SQL scripts to that database by using this activity and the linked service. So there is no need to create a dataset that would contain any metadata about this linked service. The second thing that we can configure with this activity is the script type. So is it going to be query or non-query? Basically, what is the difference between these two? The query will return some values when the script activity runs and makes the script activity to behave kind of like lookup activity. And the non-query activity is the opposite, so it won't return any data to the pipeline. Now we can test the script activity by setting the script type to query and writing a very simple SQL query by just selecting one as ABC. And now we can debug the script activity and see what happens. And our script activity already finished, and we can see that the output of the script activity returned the data that we defined in the query. So we have there some array called rows, and in that array we have one object, and in that object we have one key called ABC, and the value for that key is 1. Next, let's run exactly the same query, but now let's use the non-query option and see what happens. And our debug already finished, and we can see that with this non-query option we didn't get that return value, that rows array that we got with the query option. Next, let's open up the SQL Server Management Studio quickly and let's create a new schema, a new table, and insert few rows to that table so we have some data to play around with using the script activity. And let's go back to the Data Factory and let's start querying the data. Let's change the option to query and let's select everything from the table that we just created using Management Studio. And then we can debug this run, and our debug already finished, and we can see that the output of the debug returned the rows from that table. So we have the John Doe and Jane Doe row there and also their ages here. So the script activity in this case behaved like a lookup activity to the database. And what is cool about the script activity that we are not limited to selecting the data only. We can basically do every SQL operation that we want using the script activity, because the script activity will execute the SQL script in the linked service that we are providing. So, for example, we can insert a new row to that table that we just created. So let's insert a new row where the name is Jack Doe and the age is 12. And then let's debug our run. Our run went through fine. And now we can select again everything from that script testing table and see that the row we inserted there went there fine. And our debug finished. And now we can see that our output returned 3 rows, which means that we successfully added that one row to that table. Now let's check out few options that we have in this script activity. We could add some parameters to our scripts if we wanted to, and there is an option to add new parameters. And under the advanced block we can find more options. Here we can specify the timeout in minutes when our script would time out. For example, by default it's set to 2 hours, so 120 minutes. And of course this value is adjustable, and I would recommend you to adjust it according to your case. Lastly, here we have this enable logging option that would log some print statements that we would have in our SQL scripts. We could guide these logs to an external storage that is basically a blob storage that we have created as a linked service to this data factory. But in this case we don't want to do that. We can just log everything to our activity output. So let's select that. And now after we have enabled the logging, let's just add print ABC statement to our query. And now let's debug our script activity, and our debug went through fine. And we can see that in the output of the script activity we have a new property called output logs, and there we can see that ABC value. So we were able to successfully log that print statement to our activity output. And in this video I will show to you how you can read a JSON file from the blob storage to Azure SQL database using a copy data activity. And without further ado, let's jump into Data Factory and let's see how you can do this in action. Before we start to build our pipeline, we have to do some preparation work first. Let's first check out the blob storage. To this blob storage I have already created a container for us to use in this tutorial called tutorial 15 source. In this container I have one file called file1.json, and now let's check out the contents of this file. As you can see, we have a JSON object in this file, and in this object we have one property called data, and this data property is an array that contains two more objects. In both objects inside this data array we have 5 properties. We have property 1 that is a string containing some text. Then we have property 2 that is basically an integer value. Then we have property 3 that is a boolean value, and then we have a property 4 that is another object. And in that object we have one more property called for1 that is also a property that contains some string values. And our goal in this exercise would be to read in this whole JSON to the database. And for this we would be using copy data activity. Now let's open up the Management Studio and let's create a schema for our tutorial 15 sync that we are going to use for the table to which we are going to write that JSON data into. Next we can start to build our actual pipeline for this. Let's first create a folder for our pipeline called tutorial 15, and then we can create a pipeline to that folder and name the pipeline according to our naming conventions. Next step would be to add a copy data activity to this pipeline. That is the only activity that we are going to use today. And again, we want to name our copy data activity accordingly. Then we can proceed to creating our datasets. We need one dataset for the source and one dataset for the sink. Let's first create a folder for our datasets. Then let's create the dataset for our source. And this is going to be a blob storage, and then the file type is going to be JSON. Let's again name our dataset and let's select the linked service that we're going to use that is pointing to our blob storage. And then we could point this dataset to directly to our file1.json. But I don't want to do this in this hard-coded way, so I will leave the path empty for now, and we are going to use the parameters for the dataset. So let's create a file path and file name parameters for this dataset, and let's configure them to the connection page so we can parameterize this dataset accordingly. Since this is a way more proper way to use datasets rather than just hard code them point to a one specific file. So we can now create this kind of multi-purpose dataset, even though we will be using this dataset in this tutorial just for that one file. And now we can go back to our pipeline and we can configure our source to use this dataset. And here we can see the dataset parameters that we just created, and we can fill in the necessary information here. So we are going to point this dataset to the tutorial 15 source, and then the file name is going to be file1.json. And then we can use the preview data to check out that our path points to the correct file. And as we can see, this works, so we are now reading the correct file that we want. Next step in this process would be configuring our sync dataset. We want to create a new dataset for our sync and search for Azure SQL database, and then we are going to name our dataset according to our naming conventions, and then select the linked service that we are going to use that is pointing to our SQL database. Again, I don't want to hard code anything to this dataset, so we are going to use the parameters for this as well. Let's create parameters called schema and table, and then use them in the connection page to dynamically decide the schema of the table and the actual table. And as a side point, if you are not familiar with these parameters and variables in the Data Factory, I would check out my video that I have made on those that can be found on my channel on the Data Factory playlist. Now we can go back to our pipeline and configure our schema and table to our sync dataset. One last option that I want to change in the sync dataset is the table option. I want the Data Factory to auto-create the table, since we have not created the table to the database. This auto-create table is quite a cool feature in the Data Factory, since it will allow us to create the table based on the data that is coming in. Next, we are going to open the mappings page, because here we need to configure how we are going to read the JSON file. We can press import schema, and then the Data Factory will do some imports and import our mappings for us. But these mappings are not yet correct, and probably some of you can spot what is wrong here. And with this mapping, if you are familiar with the notation that we're having here, this would read the first object from the data array with this notation. So we have first their data, then we have 0, which means the index 0 of that array, and then the property 1, for example. But this is not what we want, because with this setup we would end up reading only the first object from that data array, and we want them both. That's why we have this collection reference setting here, so we can use it to select the array from which we want to read from the data. And here we can see that Data Factory is already suggesting us to use the data array as the collection reference here. After we have selected the data as our collection reference, we can import our schemas again, and then Data Factory will do the mapping properly when it knows that we want to read the data that is inside the data array in our JSON file. And now we can see that our mapping looks a bit different. First we have there the data array, and then we have the properties that we want to read and their data types, and then we're pointing them to a column name in the database. So basically the property name will be the same column name in the database, so they will map one to one. Also, the Data Factory knows how to map the property that is inside the property for the nested property. So basically with this setup we will end up having 4 columns in our database tables, even though we have 5 properties, because the property 4 is an object and we are just getting the contents of that object and not that object itself to the database. Also, in this mapping we would be able to select some data types for our data, but it is okay to leave them as empty, and then the Data Factory will kinda guess what would be the correct data type for each column. And this usually goes all right, but maybe a better practice would be to have them set here, but let's just go without setting them for now, because I know that I have a very simple JSON file and the data types are very easily guessable. But if you have, for example, some sample file that you are not sure of those data types, then would be more ideal to probably set them up, because if for example, some number would look integer in your example file, but it is possible to have decimal values there, then you would probably want to set it as decimal or float type in the database. Now we can actually proceed and debug our run and see what happens. Our debug is running and it already finished, and now we can check out what we have in the database. We have there a new table in our schema tutorial 15 synced, and this table is called file1. And let's see what the contents of this table look like. We can see that there are 2 rows. That is correct, since we had 2 objects inside our data array, and the data looks the same as it was in the JSON file. So we have managed to successfully read the data from the JSON file to the database. We can also quickly check out the data types that our data factory created for these columns when we didn't specify them and we didn't have table ready. So basically those string values map to n varchar and they are maximum length. So data factory used that because it couldn't decide what would be the optimal n varchar length, so it just used the max value. And our integer mapped to big int, that is a big integer. Then our boolean value mapped to bit in the database, since we don't have boolean value available. Bit is basically 0 or 1, meaning that true value will map to 1 and false value will map to 0.